Alright. Hello. Hello. Welcome. Well, hello and welcome back to another episode of 5 Minute Materials. Today, fuck materials. Fuck that material shit right off. We are doing PID controller for... This is so dumb. This whole thing's so dumb that I'm doing, but like that's why it's funny. You know? That's why it's funny. It has like a couple of upsides. But the main thing is that what we're doing is just funny. It's just like, you know. It's just a chance for us to introduce another vector of chaos into the game. What is all this dust? Maybe it's coming from the air vent? I don't know. Maybe it's asbestos or something. No biggie. Jed M. Hello. First, indeed. First across both platforms. Danielle. Hello. Isaiah. Let's go indeed. Azdaha. Waving emoji. Amethyst crying emoji because my internet sucks. But I think it's a bit better now. I might slowly increase the bit rate as we go along. But usually with like streaming Unreal and stuff, a low bit rate isn't actually that bad because like it's mostly stationary all the time, so it can kind of like, you know, encode things and whatnot. Does your game have either magic or practical? It's like 90% practical and 10% magical. I kind of think of the magic element as more like supernatural rather than like magic. If that kind of makes it like spirits and that kind of stuff, rather than just like cast fireball from a wand using, you know, some shit. But yeah, it's mostly what's it called? Practical. Or like practical or kind of like science fiction in the way that you can just kind of make up some bullshit about like, oh, it's like a rare mineral that like you know, when it gets charged with some kind of energy, then it like, you know, it heats up and whatever. No, we're not prismatiscaping. We will be at some point in the future because I want to do an update now that 5.5's come out. But we are currently doing some really dumb stuff. So this is what we've been doing the past couple of sessions, or the past session, is turning our characters into ball bots, essentially. Which probably seems dumb. You're probably thinking, what the fuck is wrong with you? Like, why not just use the default character movement? And my answer to that is, you know, suck my nuts. I do whatever I want to do. But yeah, so this is the first prototype. It's got a bunch of issues because it's kind of just hacked together as a proof of concept. Like, for example, if I control it, it never reaches maximum speed because it reaches, what's it called? Steady state error. No, steady... I don't know. Essentially, it's like... it's reaching an equilibrium point that isn't our target point. Which is why today we need to learn about... Also, yeah, it's gonna just, like, fucking fall over and shit. Because it can't climb things yet, because there's no... there is no integral. But, okay, so the cool thing about this setup, right now, is that we're literally never emitting a linear force on our character. So our character is never actually just, like, being dragged along by a magical force, like most character controllers. It's only... I've restricted it to only be... We can generate torque of the capsule, which is there to kind of represent how the fact that humans stand on 4 points of contact. You've got the back of the foot, back of each foot, and the front of each foot. And around that, you can essentially just, like, move your center of balance. So that's something that we can do. And then we're only rolling the ball, which is there to simulate our feet. You know, like, if you just give a person 100 feet, then they'd always have a single point of contact, or multiple points of contact with the ground, but it would be like, you know, they'd have a constant point of contact with the ground, and it would kind of look like a ball. Sort of in the way that, like, a centipede would run, but it would be a person. And so, with that... Oh, and there's also a suspension between the ball and the capsule. There's way too much damping on that. Oh, yeah, that's the other thing that's... Okay, yeah, see how, like, undampened it is? So, yeah. If you capture a real-life frame of every leg position type... Yeah, if you're, like, on a treadmill and you, like... And you took every frame and laid them over the top of each other, it would just be a circle, basically. So... Just a recap for anyone that wasn't here last time. The main pros of doing this... Well, so the cons are... Honestly, I don't even, like... I honestly don't think this is any more expensive. I think this might even end up being cheaper than the regular character controller, because it's all... Like, there's less being done on the game thread, and most of it gets offloaded to the physics thread. So in the game thread, all we're doing is the PID, like, error correction loop, which is just like... It's like, get the difference between our target and our current. That's the error. Accumulate the error over time. That's the accumulated error. Get the rate of change in the error. That's the derivative. And then a factor of the derivative, a factor of the integral, and a factor of the proportional. They all just get added together. That gets sent to the add force. And that's literally, like, you know... That's literally it. That's, like, all... Well, that's what this ball is. This is me doing, like, an actual PID layout. You okay on the back? Is it? No, I think that's a pot plant. Yeah, that's a plant. Almost, but they probably will be in here soon. Boy Cat's like... Oh no, there she is. Okay, no, never mind. She escaped me. Hello, Miguel. Not up there, please. No. No. God, you're a fucking menace. Hellcat. You won't be able to get through there without knocking all my lights over. Can you just not? Okay. Come here. Yeah. Quick. Yeah. No. Risky. Okay, you made it. Yeah, she might come sit down with us. But yeah, anyway, PID. So here's some balls they're trying to maintain at this point. And this is, yeah. And they do have gravity. So, yeah. This is an example of a PID controller. Whereas without the I in the PID, this would... Out of my umbrella. Get out. No. Oh my god, you fucking menace. Cat. Excuse me. God, what is wrong with these cats? They're just so... So without the integral factor, they will reach equilibrium, but it won't be enough to, like, counteract gravity. So what the integral function does is that it measures the error over time and then uses that to draw it, you know. So it's kind of like if you had a cruise control on a car and then you went up a hill, it would be like, oh, dickhead, you're supposed to be going like this many kilometers an hour, and you're still not there, like something's fighting against it, so we need to push harder, and that's what the thing does. That's what I was missing from all my other things. So these should, because I've set it very low, these should eventually, yeah, settle at the equilibrium point. Can you make a nudist cradle of characters hung from their ankles? Yes. I could do that. That's also one of the... Oh yeah, sorry, I just went on a big tangent. The reason I'm doing this, this is probably good info for you, Mitzi, because, like, you haven't been here in ages. So with the character will interact with friction in a more human way. So, like, it's not just... It's like friction... Like, I'll essentially have to program traction control for the ball. Because if the ball is moving really fast, but there's, like, you know, some physics objects on the ground, or, like, it's, like, slippery or whatever, then it will have to, like, slow down. And we can measure the difference between the velocity of the ball and the rotation of the ball, to know how much it's, like, skidding. Which means that, like, we know when the character is sliding and when they're not sliding. I'll say that, yeah. And, you know, when they, like, slip and all that kind of stuff. And, yeah, it just, like, it works with, like, you could easily just be like, okay, we're hitting the ground and the friction value is 10. Therefore, you know, we can handle this slope and we can go up the slope and whatever. But in this case, it's like, if there's, like, a slight slope, but then there's, like, a bunch of... I might even just do, like, a little thing. Let me just go, like, on begin play. Add component. Add component by class. Can I just add mesh component? Add static mesh component. We're going to do a for loop. For loop. Yeah, basically we had like a bunch of little rocks on the ground. Or like, there's like weapons and stuff all over the battlefield. Or there's like bodies and whatever. The friction becomes like, rather than just surface friction, it's like you'd be able to trip someone over on marbles, but like physically. Does that kind of make sense? Because like even if marbles are made out of rubber with 100% friction, if you step on them, the perceived friction is 0 because, yeah. And set mesh. Oh no, I can just do that in here, can't I? You guys are finding getting bruised shins? Yeah. Well, see, that's another thing, Jed, is that if this character runs into a fence really fast, they will tip over, you know? And if they go past a certain angle, then I'm just going to ragdoll them. Because it means that their center of gravity's, yeah, it's like unrecoverable. So I'm just going to make them eat shit. So, like, I feel like it will add... I obviously don't want it to, like, hinder the player in an unfun way. So I still want the player to just be thinking, like, oh, yeah, like, I'm moving around, WASD, whatever. But then when they run into, you know, a fence really fast, or they trip over a body, or whatever, they can still technically correct themselves. Like, if you were, like, tripping, but then you said, okay, go back this way, it would be better than... I'm gonna... Yeah, I don't know. You can add, like, a skill element to it. And then the other thing is that I want characters that, like, weigh different amounts, or have lots of armor on, or they have, like, a really heavy backpack, or they're injured, or they're drunk, or whatever. To all... Like, I'll tune their PID system separately. Or, like differently. So the actual, like, values in the PID, like integral, proportional, derivative, whatever, will all be affected by character stats. So, like, for example, the derivative factor, if I put it really low on these spheres, you saw that they, like, arrived at this point, whatever. If I put it really low, then they're going to kind of oscillate, you know? They're never really going to reach that equilibrium point because the damping just isn't there. Which is kind of like a drunk person. Like, they kind of stumble around and they overshoot where they want to be. And then I can add noise to that and whatever. And then, you know, if they, like, bump into something, they won't be able to error correct quickly enough. So that's kind of the idea. When C++, I'll be C++ing this once it's done. Which will be fun. So we'll squealy 100 characters on screen. It does, but, like, not as much. Girl cat. Hey. Why are you being such a little naughty? It does, but not as much as the regular character movement. At least, like, in the state that it's in right now. Because again, a lot of it, like in the regular character movement stuff, all of the like acceleration and velocity and collision, it gets done on the game thread with like line traces and sphere traces and doing a bunch of math and all that. All we're doing is calculating one value and then sending that to the physics, like the whole physics system, which is designed to like the physics system runs on like a kind of, fuck, what's the word for it? Like a... Not EQS. What's the thing? ECS, Entity Component System kind of thing. Like, all the physics bodies, at least this is how I would do it. This is how I presume it's done. Because, like, with Blueprint or, like, with game thread stuff, like, yeah, we have to go through each actor and do their tick stuff. Which in this case is calculating a bunch of shit. But... And then we just add, you know, a force, like the outgoing force, to the physics, primitives, whatever. And then on the physics side of things, it doesn't really go like... And because, like, in this case, it has to go through the actor, go through this actor's movement component, this actor's other component, blah, blah, blah. And it goes like actor does all of its stuff, then moves to the next actor, does all of its stuff, moves to the next actor, does all of its stuff. Whereas, like, if you could presume that every character has a character movement component, then it would be more efficient to just be like, you know, okay, here's all of the values for all of the character movements. We're just going to, like, mass compute them. Bam. You know, so it doesn't have to jump around in memory and, like, cache misses and all that kind of shit. So that's sort of what... That would be what the physics engine is doing. And so we're essentially just, like, setting up a value to then get mass computed by the physics engine. So it's sort of... presumably... would be more performant, potentially. I mean, like, you saw those, I mean, I can just get a bunch of these guys. They should be self-stabilizing. Oops. Although they are doing debug line traces to know if they're on the ground or not. So that would be eating some juice. Let me just disable that. Where is it? Yeah. Is that... What are you doing? Character feet. Event tick. Why are you... Right, if it goes below thingo, don't care. That's the mesh. So the mesh works, that's animation stuff. Reminds me when I duplicated that house 100 times, which reminded me of the UV unwrapping the houses, which made me shudder. God damn. Yeah, UVs are something. They are something, I'll give them that much. Why am I not... Oh, I didn't... Oop, hello, brother. Oop. Just doinking him. Logic? Hello, cat. Why don't you sit up here? Up you get. Gonna flop down. Let me get those grass seeds out here. You stay. Sit. Sit. No, sit. No. Sorry. Right, yeah, characters. It's like if I get... Oh, I also need to recap my frame rate just while I'm streaming. Frame fixed. Fixed frame rate. Bam. 60 FPS. Thank you. So yeah, I could just get like a lot of these characters and kind of yeet them together. And again, it's like I'm not noticing any bullshit happening. I can also like obviously disable this when like probably in towns they don't need to be so complex, so I can probably just have a dumbed down version. At least for just like, you know, townspeople if they're not, you know, if they're not in combat. I think as soon as a character enters combat, this becomes part of the combat. Like, you know, charging into them, like bam, and like, you know, if there was something for them to trip over on, you could bash someone into a fence and like, and they'd fall over, you know. Or, like in combat, like crowd mechanics. So like a bunch of characters. Can I like, oh, you know, I can do this, but then set the individual scale to be 1, yeah. So if I bump into one character and I weigh 70 kilos, versus if I bump into all these characters, they're gonna like, you know what I mean? They are gonna like push back against me way more. So yeah. Lots of stuff just gets, like, solved by the physics engine. Which you would have to, like... Imagine trying to, like, fucking program, like, you know, kind of like, yeah, like crowd mass mechanics without the physics engine. Like, it would just be fucked up. Do these work if they're bigger? I don't think I've actually scaled it properly yet. Yeah, no, I haven't. Yeah, I think like for what I'm trying to do, where like everything's grounded and kind of predictable and chaotic and all that kind of stuff, this is like a decent solution. And like it's gonna get more complex and whatever, but you know. And there's also suspension, like in the legs, you know, or in the ball. There's ball suspension. Doink. Oh, sorry. Yeah. Ninja Puss, very interesting. Going to go to PCG. No worries, no worries. Thanks for hanging out. Thanks for hanging out. So yeah, this was my initial actual prototype of the thing. This is like the animation stuff down here, which I might turn off for now because it kind of looks goofy because I haven't done it properly. But then, yeah, I obviously ran into the issue where we couldn't reach max speed. I essentially, like, I think I ended up, without really knowing what I was doing, making a PD controller, not a PID controller. I think, honestly, just adding the integral to this would make it work. But the problem is that all the bowl is trying to do is just catch up with the tilt of the capsule to then make it go forward. But obviously, like, and like, it looks correct here. Like, when we start, you know, like, we lean forward, we accelerate, and then we kind of reach this oscillating bullshit point. So I'm not really sure how I want to do it, but I have a video about cascaded loops and discrete systems in PID controllers, so I'm going to watch that.
Approach and think about your problem. Therefore, I think they are worth spending some time to discuss in a bit more detail. I'm Brian, and welcome to a MATLAB Tech Talk. What is cascade control? Well, to answer that, let's go back to the example we used in the second video of this series, an altitude controller for a quadcopter drone. Recall the block diagram for this system. We start with a reference altitude. This is the altitude that we want the drone to hover at. And then this goes through a comparator to generate an error term, which is then fed into a PID controller that generates a propeller speed command. This is commanded to the propeller, which begins to spin up, and the output for this block is the true propeller speed. The propeller speed generates a force that acts on the drone, adjusting the altitude. And finally, the altitude is measured by a sensor and fed back into the comparator at the beginning. This is our classic feedback loop, and it has a single PID controller like we're used to. But now let's focus in on the propeller itself. Again, the propeller command is the input, and the resulting speed is the output. But if you recall videos 5 and 6 in this series, we talked about motor control. And what is a propeller other than a motor with a fancy bit on one end? So instead of a single block labeled propeller, this is actually a small feedback loop itself. There's the command.
And that's because it's a physical propeller on a physical motor, and the motor itself isn't completely instantaneous, you know?
Which goes through its own comparator, and the resulting error is fed into a PID controller. The output of the controller is voltage, which is applied to the motor, causing the motor to spin. The motor speed is measured by a sensor and fed back into the comparator. So now we have two feedback loops in our system, one that controls the motor speed and one that controls the drone altitude. We can call these two loops the inner and outer loops so that we can distinguish between the two. These are cascaded loops, or nested loops. The outer loop drives the set point of the inner loop, and the inner loop affects the feedback path of the outer loop, so they're intimately connected. You would probably expect that with a system with two PID controllers interacting with each other, that this would require a slightly different approach to controlling it versus a system with just a single loop. And you would be right, but it may not be as different as you expect. The first question might be, why design a system with cascaded loops in the first place? I mean, why not stick with a single loop approach that we have so much experience with? For example, a single loop approach would be to design one PID controller that takes altitude error and outputs a motor voltage. In this case, the altitude directly drives the motor voltage. There's no middle step of first commanding a motor speed. Well, here's two reasons. The first is that with a cascaded approach, it can be easier to isolate problems in the system. In our single loop example, if we have a problem with the motor, then it can be difficult to test just the motor separate from the rest of the altitude system. With the cascaded loop scenario, we could run the motor controller closed loop and determine if the problem exists with the motor or with the rest of the system interacting with the motor. The second reason for cascaded loops is that multiple groups can work separate parts of the problem. One team might build and design the motor controller, while another team is responsible for the altitude controller. This is especially the case if you buy a motor with an integrated motor controller. The supplier that built the motor will have already designed the inner loop for you, and you just need to incorporate the outer loop around it. But a more important reason to have cascaded loops is to run them at different speeds to address different problems and sources of error. The motor controller can respond quickly to local disturbances, whereas the altitude controller can be tuned conservatively to reject sensor noise and increase stability. For example, in cascade control, let's say that the propeller motor takes 10 volts to run at 100 RPM, which we'll say is the speed required to hover the drone. Now we add some disturbance in our loop. Maybe the battery voltage drops because another high current device in the drone is turned on. Or perhaps the lubricant in the motor bearings get hot and the resistance drops, requiring less voltage for the same speed.
True.
In both of these cases, the inner loop motor controller can sense this error and adjust the motor voltage in a fraction of a second, so that the propeller speed is barely affected.
So in our case, this would essentially function as, like, if we hit a slope and we want to, or like, you know, if we hit a little ledge and we want to kind of go up the ledge, that would be, yeah, like we meet resistance, we're not meeting our actual desired velocity, and so this would like jump up for a tiny bit, you know? Like that. In that case, it was like, oh, we needed more juice. Whereas the overall system, that being the torque of the main capsule, you know?
If the inner loop is fast enough, then the motor disturbances wouldn't even be seen by the outer loop, because there wouldn't be a noticeable change in altitude. This would allow the outer loop to be much slower, and only respond to relatively slow disturbances like wind gusts. Now, if there was only a single loop, then the altitude controller would have to sense that tiny change in altitude, and quickly adjust the motor voltage in that fraction of a second. If we tuned the outer loop to be that aggressive, then it would respond quicker to changes in altitude. But it would also respond quickly to altitude sensor noise, and that's not ideal. So it's a much better system to have these cascaded loops, with each loop targeting a different set of reference points and disturbances.
This would also be like, if we know, like, if the ball is like, oh yeah, we should be moving at this velocity, like our target velocity is, you know, maybe like 400, which is a jog for our character. If anything, if it goes over or under, it can quickly adjust. So for example, if it starts slipping, because we're like going up a slope or whatever, or we like jump off something, we obviously don't need to like spin up and go out of control. Or if we meet resistance, like, you know, we fall in water or something, and we don't want to, like, you know, these poor guys, they just keep... The ball needs to be thinner than the capsule. That's one of the main annoying things. Let me just... Where are you, testy boy? Basiador, hello. Yeah, so we're physicalizing the character for better just interaction with other characters. Oh wait, that's the height. Oh no, the height can be bigger, can't it? Maybe you go to 24. And the ball can be... That goes to the knee? Yeah, yeah. The ball can... be 22. So it's slightly smaller. And this guy can just get a bit bigger. Oops. That's about right. Like stability... Yeah. Like literally like that. Or traction control, I think. We call it in Australia. Maybe it's called that everywhere. But, yeah, basically that. Yeah, when the ball is smaller, it's sort of... I can make the ball bigger. Well, no, obviously they will... like... correct, but yeah. Looks so dumb. Yeah, at least they're not tripping over each other now. At least they're not affecting each other's balls. Oh god. Medieval robot? Yeah. Imagine this, but with like a jousting lance, you know? Yeah. Oh, so this ball's gonna like fucking yeet us in the head. Stabilized, you know? And again, this doesn't have any... it kind of has bullshit force in this. In this, it can just... Oh, no, but it only generates that when it's on the ground. But, yeah. You do some research to follow you. Yeah, it's a bit crazy, but...
Okay.
I think this PID controller is like... It's such a universal concept that I'd actually recommend like any, you know, any game developer to kind of know the basics of it. Or like to at least set up a single loop PID. Because like you could use it for, well, obviously character movement. You could use it for like rotating platforms. Or like moving platforms. All that kind of stuff. You could even use it for like... I don't know, you could do like a PD controller, maybe a PI controller. For like health regen variables and stuff. But yeah. Prototyping very important mechanics is really good. I think this is actually like worth doing. Like a lot of the stuff I do is just like dumb as hell. But I feel like this is, you know, this is actually like, yeah, like a core part of my like gameplay vision. Which is like, yeah, like when you like bump into someone, they don't just like teleport out of the way or whatever. And like they resist your movement. And, you know, if there's like a big crowd of people, no one gets like priority over the other. They just all... They can like hit each other. And then all of a sudden you're pushing two people out of the way. You know? Whereas with the character movement stuff, well, in the default character movement, you literally can't push another character capsule in the first place, which is problem number one. So then if you were, like, to layer on top of that, having, like, clumps of characters and whatnot, then it's just a nightmare. And then like, imagine I'm pushing these characters around, but I've got, like, really slippery shoes on. So then what would happen is that the ball would spin out, and I'd be like... Because the walking animation is directly tied to the rotation of the ball. So then you get the effects like, oh, I'm, like, trying to push this really heavy crate, but I can't get enough traction, and it's kind of like, you know, you're sort of... You know, like when you're pushing a car, you're trying to push a car out of being bogged, and, like, your feet are just sliding and sliding, but you're still maintaining some pushing. How one do the animation when the ball's out of control? So when the character is still stable, so they're still upright, but this is, like, slipping, it will just play just like the running animation, you know, to whatever degree, you know, the ball is spinning. But because we know the rotation of the ball relative to its velocity, we know how much it's skidding out. So we can then adjust the animation to be like, kind of like, oh, kind of thing. But then if the character tilts more than 45 degrees, so like in this case, then I'd ragdoll the character mesh, so that this capsule and ball would just get disabled. Like, we just disable collision, they can just stop simulating. We then do, like, the typical ragdoll thing that we do in, like, you know, whatever. And then it falls over, and then when the character gets back up, we reset the ball and capsule back in its original position, ready to go. Can I convince him to put unicycle jousting in the game? Honestly, wouldn't be hard. And then the other idea is, like, for something like a horse or like a big animal, the animal would have a horizontal capsule and 2 balls. So one for each pair of feet. And they would move independently, because obviously an animal can rotate like this, and it can also strafe, and it can also, like, tail or, like, trail, where, like, you know, the back follows the front's thing and whatnot. Yeah. So, like, I'm, like, 99% this will work, like, perfectly on flat surfaces. The only problem is that, like, if the ball is bigger, right? If the ball is bigger, then capsule and 2 balls? True. If the ball is bigger, maybe I'll just set that to 1 and then do the... No, wait, what's this at a scale of 1? Oh, that's quite big. So then this embiggened is... No, sorry, not... Go back. This is... Fuck, where'd it go? Feet. Shape. Radius. What's that, like, 50? 50. So it's 100 diameter. Yeah. Okay, so if it's like 50, then... Well, yeah, obviously we get this issue where the balls interfere with one another. We trip over really easily. Where am I? Am I this guy? Can you just, like, fucking go over here? So yeah, big balls. Big balls can go up steps easier, right? Except in this case, is it because my mass is... Oh no, I'm not taking into account the scale? I can't fucking remember. Sphere radius, which is what, getting set at the start? Or is that a... No, that's here. Right, sphere radius is the... Oh no, that's true radius. Where else do I put that? Anyway, bigger sphere, more stability, and it can, like, go up steps easier. Smaller sphere doesn't trip over other characters and whatnot. But yeah, like, I don't know. It's just, I think I'll have to give it some assistance with going up steps. So I'll have to just be like, you know, oh yeah, like you're right next to a step and you're trying to move that way. Let's just apply like a thrust upwards on the ball and a thrust downwards on its like contact point, which we could like IK the foot to that point and, you know, at least that's my idea. So it should work probably. Potentially. Maybelline. So how where other characters not each other's sphere collisions somehow? Yes. That could actually work. But then we'd also run into, like, if the sphere was big, then, and we had a wall, then, you know, the wall would, we would, like, kind of trip into the wall in a weird way. Because, yeah, the ball would be jutting out, and therefore we, like, when we hit the wall, doink, we wouldn't, we could potentially, like, fall, we could trip on flat surfaces in a way, you know? If that makes sense. Oh. I think you don't account gripping, some material grip less or more, better or worse. So at the moment, I've got like 100% friction on the ball, and I think 70% friction on the bottom. If I do set, let's say I set this to be glass or something, or fizz mat, ice. The characters will just like fucking eat shit. Oh no, it's not too bad. Well, I mean, they'll try and like, it'll spin out when I try and... No, you don't want it? Okay, well, probably because the character's foot itself is too grippy. Where's viewport? Where's like all the... Where's the stuff? Where's the... Oh, that's... No, that's test character. Where the frick is the... What's this thing called? Window... The palette? No, not palette. That's dumb shit. Window... Components. There it is. Feet. Fizz. Fizmat. Ice. So yeah, the characters won't be able to stabilize now. Because they just spin out and die. And that's something I want to adhere to, which is like doing the step up stuff requires like a tiny bit of cheating. Where I emit a linear force on the character, like a thruster, you know. Whereas with the current setup, we only use torque. Like, the entire motion of the character is torque only. It's funny. But yeah, I'll go with, like, rubber for now. Just while we're kind of... maybe I'll do, like, what's dirt? Dirt's like 70%, I think. And then... No, let's do, like, 100%. You know about this being funny? Yeah, it is kind of wacky. So anyway, I just want to finish this video and then...
Now that we have an understanding of why we need cascaded loops, let's quickly discuss a few ways to tune them. First off, if the inner loop is much faster...
Should be a combination of torque and grip. Yeah, exactly.
The bandwidth of the loop is at least about 5.
Yeah, there's never any just, like, move the character magically. It's only torque the body of the character, which is like when you're standing still and you can lean forward or lean back because you've got 4 points of contact on the ground and 2 feet. You know, you can essentially just generate torque. And then your feet essentially just catch up to you falling over, and that's how you get motion. And that's the rotating sphere. But obviously, that's prone to friction, just like when we're running. Like, if you're running and you're expecting it to be grippy and whatever, and then you hit, like, a muddy section of grass, and it just, like, slips out from under you and all that kind of thing. Yeah.
5 to 7 times higher, then it is possible to tune them separately. For our drone example, we could tune the motor controller first, and make sure that when we command a speed, the motor spins up quickly with the performance that we want. And then, since the inner loop is so fast, when the outer loop requests a motor speed, the motor spins to that speed quickly so that to the outer loop, it might as well be instantaneous. Therefore, to tune the outer loop, you can make the assumption that the inner loop doesn't exist, and that the command just goes straight through. In this way, you're essentially tuning 2 single loops exactly like you're used to. If the 2 loops must operate at about the same bandwidth, then tuning becomes a little more difficult because we can't claim that the inner loop is fast enough to be instantaneous. Now the inner loop performance does affect the outer loop. I'm going to highlight 3 different ways to approach tuning here, but I'm not going to go into detail on any of them. If you'd like more information, check out the links below. Alright, the first way is just an iterative approach. This method requires you to tune the inner loop first with a guess, then tune the outer loop while the inner loop is running. If this isn't sufficient for both loops when you're done, then you go back and tweak the inner loop again and iterate back and forth until you have the performance that you're looking for. An easier way, however, is to just treat the system as a multi-input, multi-output system, rather than 2 cascaded single-input, single-output systems. Using a state space representation, you can treat the whole model as a single dynamical system and tune both loops simultaneously using a variety of state space tuning methods. Finally, we can use software to auto-tune them. Just like I showed in the last video, the auto-tuning capabilities of MATLAB and Simulink can be used to tune the 2 loops at the same time.
Auto-tune.
Alright, there's obviously a lot more that I could cover on cascaded loops.
Yeah,
but right
tell
now
me
I want to
about
turn your attention
Discrete.
to a topic that will affect almost every PID controller you create. And that is a discrete PID controller. Similar to what I just did with cascaded loops, for discrete control I just really want to use this as an opportunity to introduce the topic to you, and maybe give just enough information to explain why learning the topic is important, and how a discrete PID controller differs from a continuous PID controller. As always, links to more information are below, including a series of videos on discrete control that I made on my channel. Alright, so why discrete control? Why not always treat time as a continuous variable, like how we experience it in real life? The reason is because the controllers we design are usually run on digital computers, and digital computers don't run continuously, but instead update at each sample time. For example, that means that if a computer process is running at 1 Hz, then once a second the controller reads the sensors, performs some calculations, and then commands the actuators. The actuators keep that command for the full second before receiving a new command at the next sample time. Contrast that with a continuous system, or analog computer, where the actuator command is changing continuously and smoothly.
Right,
The result
but
differs more and more. If the lights are on and your eyes are open, for it's just on, or once every before. Running since they. So a typical approach to tuning a discrete PID controller is to first tune it in the S domain, and then convert
Yeah, no, I
it
don't
to
think
the
we
Z
need to
domain.
worry about discrete, because that's essentially what we're doing with delta time. We're like, yeah. I need to pee, and there's an ad starting, so BRB. Hello, I'm back. How is everyone? I might tie my hair up, actually. I mean business. When the hair is back, then... I don't know, I'm trying to think of something that rhymes. Oh, and the Inferno music? Let's pump this shit. Alright. Alright, let's go. Okay, feet, thing, blah, 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 blah. So, first, let's just get our... This one, we're going to duplicate this. This is called our Prototype 2. This is now our new one. Yeah, this does remind me of, like... Yeah, it's just... What a fucking tune. Just with like the trumpets and stuff. Basiotto, I don't know if you guys started doing these on programming or do you have some professional history? I started game dev and 3D stuff for the first time during COVID. So like 2021, 2020? Whenever that was. I don't know, like about 4 years ago. And prior to that, I was an audio engineer and musician. But then, obviously, there's no work for like either of those professions during COVID. So I was like, you know what? Game development. So that's when it all started. I've just been doing it full time. I've been a full-time doodler since then. So yeah, that's literally it. Like I've never worked in the industry or anything like that. I'm just a doodle man. Oh, good, Jed. Have a ripper, and do you... No, it's... You don't stream tomorrow, do you? You have Monday, Tuesday off. Bugger. All right, let's start tuning this. HugeCon in industry is basically zero energy doing own things. Yeah, I can imagine. That's like one of the main reasons that I decided to do like YouTube and streaming and all that kind of stuff is because if you can like turn, you know, doing your own thing, if you can like monetize doing your own thing to the point, like obviously I make less than minimum wage, but I also like, you know, live in the countryside and don't do anything other than this, you know, and I cook all my own food and all that kind of shit. So like I can live on not much money, which gives me, you know, a lot more time to like just do dumb shit like this. Not gonna do money. Yeah, like conflict of interest and non-compete and all that kind of stuff. I have like done some work for other people. But when I did, I was like I'm happy to work on it, etc., but like I can't just like take a break from streaming or take a break from YouTube while I'm on your project, because it doesn't work like that. Like you can't just, I mean, obviously I have taken a break from YouTube, you know, because like I'm just sick of it or don't have any ideas or whatever, but you know, it's like a momentum kind of thing. I was like, yeah, look, I'll do the work, but I'm going to be streaming and I'm going to be doing my own thing. And, you know, if you can't handle that, then if you can't handle me at my worst, then you don't deserve me at my best, you know? Queen. All right, let's do the thing. So, I want to start this with very little damping. With like no damping. Damping is no. Because, yeah. Basically, yeah, damping bad. I kind of do want to set the center of mass. What would that be though? No, well, I guess technically we have center of mass because we have this and then we have that, And that would put the center of mass slightly lower of the entire system. So that's fine. So without damping, everything goes a bit fucky. Which is fine. That's expected. Yeah. We have a max, dude, max power. Let me just see how this goes. So we have our sensor. We have our PID. We have the output. And then that zoop goes back into here. And so... Oh, so I can probably put my bitrate up now, can't I? Can we try 2K? It's holding up. Alright, the quality probably just got a lot better for everyone. Double quality. Like... Sorry, I just muted my microphone somehow. I don't know. Sorry, I was saying, we as a human, we lean forward. You know, on this one point, then the ball catches up. Zoop. Catches up. But obviously, as it catches up, this generates velocity this way. So when we reach, like, a steady, you know, velocity forward, we're not leaning over as much. But the ball is still rotating, you know, at our desired speed. So we essentially need to... We know our total velocity. The velocity of the middle of the capsule. We also know the velocity of the feet, but that's not super relevant. I think we measure the character's velocity from the center of the ball. So this is our, like, character velocity. And then there's obviously the torque of the ball, which we can call I don't know, foot velocity. And then all this does is tilts. And this catches up. This will reach a point. It's weird because at this, if the ball is just trying to catch up to this, then when we get to this point, when we're already moving fast enough, then the ball's just going to slow down. You know what I mean? So, like, the ball kind of has to... Like, if we take... No, because... Tilt velocity increase, then increase torque and opposite. Yeah, exactly. And that's how we do it down. Here. We get the up vector of the character body. So the tilt. We cross that with up. That's our stabilization vector. We then do a cross with the target velocity, the current up vector, and across that. Yeah, target velocity, meaning we want to go this way. That adds torque to the body, which makes it tilt over. And then... What's this again? Oh, that's just to rotate the character around. Where's the foot stuff? Here. Stabilization. Yeah, so this is just trying to get back underneath the capsule, right? But I don't know if getting back underneath the capsule is, like, enough. Because, like, with the... Well, yeah, obviously this is going way too fast because I don't have, like, 1,000,000 degrees of damping going on it. So if I just, like, put damping on it, which is cheating, because that's, like, saying we're underwater. But if I've got damping on it, like, we can't reach our desired speed, which is 400 units. We're only getting to 200 units. Even if I get past all these dudes. And I'm pretty sure that's because... Because, like... We could be moving faster whilst not leaning over quite as much. You know what I mean? Because, yeah, when we start, we lean over more, but then the ball starts catching up, and then... Yeah. Let me plug the animations back in so you guys can see that it isn't a dumb idea. This is it with, like, animations going. I'm not completely stupid. Oh, but I obviously changed the... Okay, well. Why is the character moved down now? Ah, because we don't measure the radius properly. Oh, yeah, anyway. Yeah. Humans naturally can't stop... Yeah, exactly. They need to either slow down slowly or they need to, like, brake by leaning the other way and, you know, kind of moving their feet a little bit and then going back this way. But then, like, if the floor is slippery and we try and do that, this will skid out and it won't be able to balance itself, which is funny. Because if you're, like, if you're running and then there's mud and you try and change direction really quickly, your character will slip over, which I think is hilarious. So we basically need to... I don't know. We need to just... Bleh. You know what I'm saying? This needs to be scaled. Sphere radius. So that it knows where to put the character thing. And drifting, exactly. Prismatica drift. Prismatica drifting. The other thing about this, which I'd thought of earlier, but it's the fact that the orientation of the character is also done in physics. So, like, if you glance off a character, your character gets rotated slightly, which happens in real life. Like, if you bump into someone, it adds torque in, like, you know, the z-axis. You can see him, like, kind of zhuzhing, you know. How tuning are you relying on engine physics? Yes. Yeah. For better and for worse. I mean, it's like 99% positive. I haven't run into any issues with it. And it is very efficient. Because it runs on like an ECS kind of... Like, we just supply it, oh, what are the forces that we need to add to our characters? That gets done, obviously, you know, like, per actor. But then the actual solving of it gets done by the physics engine. Which is really cool. And that gets done in, like, a batch. Like, it just has all of the physics bodies, it has all of the values we want to add, and it just processes them all at once. So it actually ends up being more efficient than having a ton of individual, like, kinematic, you know, like, manually calculate the acceleration, move the character, blah, blah. And, like, you know, manually damp the character and make them slow down and all that kind of stuff. So I think this is a pretty interesting approach. And obviously we like put the hands out and they can like push things. And they'll be able to slip as they're pushing things. I think this is gonna be sick. This is gonna be sick. Just like, trust me. Trust. Alright, let's yeet all of this. Let's yeet all of this. Bam, it's gone. You're gone. You're gone. We're still going to keep these line traces. This should be scaled radius. So step 1 is getting this working with a human. Step 2 is going to be generalizing it so that we can set it up in like any configuration. Yeah. Like on a quadruped as well. And maybe like a slug or like a snaky kind of thing. No, I don't want to do physical fucking snakes. Imagine doing physically simulated like snake weird shit. That would be funny as hell. Yeah. And then obviously we need to do navigation. But navigation shouldn't actually be that hard once the character moves properly. Right, let's see all of this stuff. So we probably want to start functionalizing things. These are all... Do I even need... Is that even being used anywhere? It's not. It's literally just being set and not used again because we don't... Well, no, this system should... Because I was just thinking, right? If our character is like... Let's say our character's holding a crate. Like a big, heavy crate out in front of them. What we could do is... like, attach that crate to the character, IK the hands to it, you know, whatever. That then changes the center of mass to be slightly forward on the character. Therefore, the character would want to be leaning backwards slightly. And then, like, if someone bumps the crate from the side, it'll kind of spin the character around wildly, which would be funny as fuck. But that means that our up vector is actually not just up on the capsule. It is from the center of the sphere to the center of gravity, wherever that may be. So, let's Well, I can get rid of this because our center of mass is whatever. You can fuck off. Initial distance between body and feet, I also don't think is necessary, but whatever. How do we get, like, get location... Get location, get mass? Or get center of mass? No, get center of mass, get mass. What's scale? No. So get center of mass, get mass. We then... Like the idea of flying objects or projectile throwing you off balance. Yeah, exactly. That's what we're doing. See, I'm gonna have to hard code this to begin with, but it'll be worth it. Character feet. Oh no, because the feet. No, we do want to know. We do want to know. It depends on adding crawling. Yes, I think for crawling... For crawling, we either turn the character into a quadruped. So once they're on the ground, they become like a, you know, a dude that looks like this. Basically. Obviously that could nest inside it slightly or whatever. So either this or fully physical crawling, where like we simulate the character's mesh and we play a crawling animation which is animated in a way that it actually functions as like it would actually move the character along. And then obviously, if they're on their back, they need to, like, get onto their front. But you could also crawl while you're on your back, right? You could, like you're trying to, like, get away from something quickly and whatnot. So if your character falls down and they're, like, ragdolling and they haven't found their footing yet, you could still move during active ragdoll. This is going to look terrifying. That was terrifying. Okay, get center of mass, get mass. Characters feet, get center of mass, get mass. So that's multiplied. Is this going to... If we just get the average of all centers of mass and their mass, and we get the average, so just divide by 2, whatever. Sorry, add them all. That will give us the true center of mass relative to... This is in world space, isn't it? Oh, I can just get the, get owner. Get actor location and just, like, yeet it from there. Although that doesn't take into account the fucking transform, does it? We'd want to just do transform. Make relative transform. We want this transform. This location, no rotation, relative to get owner. Get transform. Or can I just do relative location? No. Get relative these nuts. Transform. Transform location by this dude. No, I'd want to get. Transform location. I think this is what I'd want to do. Transform to get owner, get actor, transform. Bam, bam. Then multiply that by the mass, and then whatever. And then get the average. Divide by 2. Bam, bam. If we then just fucking on tick, whatever, on tick, debug sphere. Fuck you. Debug sphere. Just, yeah, do your thing. Debug sphere at this location? Well, no, that's the actor's relative. So if we then add that to actor location. Oh, get owner. Get location. Why does it do that every time? Hello. Sorry, it looks like every fucking night at 2 o'clock, my internet just whoop, just decides to disappear and then come back. Yeah. Are we back? Hopefully the audio doesn't go out of sync again. That's so annoying when that happens. But it looks fine now. I think we're fine. Internet's still shit, but it's recovering. Maybe. Hopefully. Hello. No. Ugh. Audio's okay? Okay. Cool. Do you recommend you use new physical control plugin from the Epic? Seems like it's good. Cannot find any good documentation. I do recommend it. It's a big improvement over the old physical animation stuff. It's just like a lot more controllable, hence physical control. For documentation, there's a few videos on the actual Epic, not store. What do you call it? Yeah. On the Epic thing. Epic YouTube. Yeah. Showing bitrate. Yeah. I tuned it down to 1000 while it was kind of recovering. Let me put it back up to 2000. Print strings. True. Yeah. That would be very true when I do this. Okay, I've disabled it now, which is good. I will keep that in mind, though. I do forget that having a bunch of moving text is like a killer. So this is get the weighted middle point, get actor location, this minus that. Oh, sorry, this minus that. Actor location is at the actor location is going to be the feet. Get feet. well, no, that's not that. This is get feet, character feet component. Get scaled radius. And then you... Oh, we can just get the location of this. Oh. No, technically no. No. We do want to get it from the feet. Scale sphere radius. You know what? No, this isn't relevant right now. We can recalculate the up vector. Or like the desired stability vector at another point. How about mover plugin? Will you be using it? No. No. We're making our own mover plugin with blackjack and hookers. This actually would make a good plugin, I think. Which is probably why I'm writing it as a plugin. Alright, current up vector, stabilization vector. We need our current velocity. So, I'm just thinking, do I need to, like, do each element as a separate object? Like each PID loop. I guess I can just like, yeah. Just do it all now. So we don't want a max angular velocity. So when on ground, I guess the first order of business, the first order of business is just getting the ball to stabilize the capsule. So right now, they will do this. They'll go down and they will just fall over and they'll do nothing. I'm also going to disable the animation so that we're just in like ballbot territory. We hit play. They just fall down. They do nothing. It's chill, right? Some of them are just like standing up because they're not. Yeah. Anyway. Actually, let's do big. No. Fuck it. All right. So when they're on ground, we need the. Pardon me. We need the feet. Get character feet. This is the ball. We basically just want to add a torque. Add torque in degrees, I guess. Degrees nuts. Which we can using a conversion. So wait, no, torque, adding torque would be like adding acceleration, right? It's not adding velocity. Because, again, you've got to take into account the fact that the feet don't have infinite force, technically. Let's go back to this one. I did have a calculation set up, which is right here. Bam. Yeah, which converts the velocity into a dude. I need to pee. I'll be right back. Hello. Hello, I'm back. Alright, so we are getting the thing. Why is it multiplying by something? I don't understand. What are you? Race. No, well, you just need to break, right? Break. Y goes to X. X goes to negative Y. Which I'm pretty sure is just the same as doing a double cross, but whatever. Well, Paint Red Nuggets makes the plugin. So excited about that. It will in the next... the update after the next one. Which I still need to do. Admittedly. But it will eventually. I wanted to do the rivers and water stuff before the paint stuff. So that then the paint or the blood or whatever you're using it for can like flow down a river. You know? Or like if there's blood in the water and you move through the water, it will move the blood. So that's kind of why I decided to do it in this order. I'm going to save the scaled sphere radius in here. Rather than having to like go and get it every time. That will help with indirection. I'm just going to call it feet. Feet. Sphere. Radius. Any deadlines? Soon TM. Soon TM. Oh, you doing something? Is it possible to write your own event with C++ and implement it into your custom event into event graph? Yes. You just need to add the tags. Fuck, what are the tags? Is blueprintable? And if you want it to be overridable in Blueprint, there's another specifier for that. But yeah, you totally can do that. That's like really, really common to do. Is to like do some base stuff in C++ and then have it be callable in Blueprint. Blueprint native event, Blueprint implementable event. Yeah. Do I want... I might chuck this in a little function. Collapse the function. This is called XY torque to velocity. Or XY torque to linear. Linear travel. Bam. So that takes an in vec. That will then spit an out vec. Return. Or blueprint callable, yeah. There's a bunch of different ones that do slightly different ones. Do we have a better way to retarget all the game animation sample project assets and databases to own skeleton? Try to do it manually. It's a pain in the ass. I don't know. If your skeleton is really similar to that one, you can do a thing. Let me find a thing for you. Where is a skeleton? You can try the... Sorry, that's a naked woman. That's against terms of service. You can try window asset details, compatible skeletons, and then set this to whatever one the animation sample thing is using. It might be really fucky, but it's essentially like just a one-to-one remapping. So if on, you know, the game animation sample project, the character's arm moves 10 degrees, then on your character, it will move 10 degrees in, like, bone space. So if they're really similar, then that might just work perfectly. Like, for example, if you're using the Lyra skeleton or whatever it uses, but it's just like a different skeleton asset, but like the bone structure is still the same, then you could get away with using the compatible skeletons thing. And that essentially just makes it so that this skeleton can now use any of those animations from that other skeleton, but it just might be a bit fucked up. So hopefully that could be the solution. The only other solution is you could try doing runtime retargeting, which I don't really know much about. And then, yeah, the only other solution would be to do, yeah, I can imagine a really annoying targeting in 5.5 is like super simple. You'd have to enter all the new ones into the databases for the motion matching. So, yeah. 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 Contemporary tagging has a cost and not cheap. Yeah, exactly. It has to do like IK for every limb, every frame. Lady Cat's got a sore eye. For example, I have a timeline node in one BP and I want to activate that node from another BP. Yeah, you can just have like an event that triggers the timeline, you know? Timelines are kind of weird because a timeline is a component on another actor. But it's, yeah, I don't know. You think using metahumans is good practice for indie teams? It's possible to make them scalable, optimized? Don't know much about them. I don't know. I guess if you're going for a realistic style, then like maybe. I want this to go the other way around, don't I? Talk to linear, but then also linear to talk, which would be rearranged. Duplicate. This is XY linear. Travel to talk. Talku. Which just means this. So, I should probably put in a radius here. Just in case it like changes, or if I'm just using the same one for multiple different bits and bobs. So you go here. Well, obviously I need to do it on the other one. Radius, float, you go into there, bam. Alright, so linear to talk would be... We have the radius, 2 pi. Fuck. So that's then going to what? Add torque in degrees, yeah. Whereas doing it the down here. Where are you? Here. We're getting the... yeah, this is torque to linear again. Stride velocity. But the other way, I want to be like, hey, here's an exact velocity. What is the dude? So this would be... Fuck. Does anyone know, like, geometry and shit? How many... I have a thing, and I know how many degrees is a certain length across a thing. How many degrees? I think that's what I'm doing here. But it's obviously in... Yeah. Okay. Can you be gentle? Stop fighting. Hey, can I look at your eye? You smell like pizza. Why does your cat smell like pizza? Right, I want to yeet this in here. This is our linear... And I wanted that to be what? The maximum angular. Cat pizza. Hell yeah. So that's new max... No, so this is still velocity to angular. Whereas this is the other way. Oh yeah, no, I do want it linear to angular. Linear to torque. Torque to linear is this. Given this torque, or angular. Maybe I'll call it angular to linear. To linear. And then we want linear to angular to be linear XYZ. I don't... Do I have to untransform it? Oh, this would untransform it anyway, because it's a negative dude. So then, linear, x, y, z, whatever, divided by pi to r. So pi to r. After conversion, divided by pi to r. Can you just, like, not suck? Pi to r divided by pi to r multiplied by... Fuck you. Literal. Like, multiplied by 360 degrees, because this is in degrees. Angular degrees. Your performance slowly degrades over time, about 2-3 hours. I restart UE, it's fine until I start degrading again. What version you use? Mine's 5. I'm using 5.5. I haven't noticed any performance difference, but I haven't been doing very heavy stuff. Maybe double check your... like... your RAM? Maybe, like, the garbage collection is just... Well, there is no garbage collection in Editor. Because if something's loaded, it'll just stay loaded until memory overflows, basically. And maybe it then starts replacing things, but... Yeah, it sounds kind of dumb, but it makes sense in a dumb, weird way. Okay, so if we had character feet, we want to add torque in degrees, we'll do acceleration change. We want to get the... stabilization vector. Which is the up vector, cross vector. We want to do something of this. Was this ever... Let me just check this. When we were doing the feet, we literally just get stabilization vector, and that's the torque of the feet. Well, some proportion of the stabilization. So if I just said this times big number, you know, this would be our proportional value. Adding torque. We're not setting angular velocity. Wait, what is the angular velocity? It is just setting. Yeah. But adding torque is additive. So if this was like, I don't know, a big number, 50,000. Chuck that in there, whatever. This will then try and stabilize our character. Yeah. Torque tour? Wow. Yep, character's just stabilizing. And obviously oscillating. So stabilization vector is just how do we correct ourselves? Yeah. All right, so we need to do a PID loop for just the feet. So if we get character feet, hello feet, and then, so like, do I want to maybe, I could create an object which is a singular PID loop. Construct object per thinger, and then it would just be like an object, you know, foot PID controller, you know, update, error, whatever, feed that all in, and then it would do its thing and spit it out. That way it's more modular, and I don't have a bunch of variables in here for, like, front foot, back foot, this foot, that foot, whatever. We can think about that after. Now, do I want the stabilization vector torque in degrees? We want linear travel to torque. But, like, what is this? It's not really anything descriptive. I think it's just a funny little... Because, like, our error... What's our error? I guess it's just the system is just rotate the feet ball until this stabilization vector is 0, pretty much. Which is just, yeah, the cross product with the desired vector. So let's do feet KP. Flight. Feet KP. Let me just put that down a fair bit. Because, like, how much is 5,000? I don't fucking know. Obviously not enough. 50,000, whatever. So we've got the feet KP, we've got the feet KI, and we've got the feet KD. Cool. We need the... Why make it so complicated? Just click the movement button X. It should be right before the multiplayer checkbox. I didn't think of that. I didn't think of that. What are you doing, cat? Ow. Okay, so we need the feet error. You know what? Maybe I will just do this in a fucking generic object. Object. Bam. This is the pris_PID controller object. And this will have... it should be a vector PID. Well, I guess it is. PID controller. We will then make a... You know, I'll just do it as a fucking... as a thinger. So variables, we have the... KP. We have the KI. Well, actually, no. Let's just call this the proportional factor, the integral factor, and the derivative factor. Proportional. Right, then we need the error. Ugh. Error, this. Well, yeah, the current error. We have the accumulated error. We have the derivative, which I don't need to actually do. This will have a function called... Oh, we also need the previous error. So this will have a function called update PID. This will only need a new... Does it need to know its target? Target and current? Yeah, that's all it needs to know. Yeah. Oh, baby, you need to clean your eye. Want me to put some water in your eye? Come on, sit down. Get your butt off the screen, please. Come sit. There you go, chicken. Sit down. Sit. Sitting. You're a funny girl. Target and current. Alright, so from update PID, this just has a return, which is just the output. Hey, excuse me. Oh. What'd you just knock over? So target minus current is our new error. Bam. I should probably put the delta in here. Just in case we're doing it like, just in case we are doing a, what's it called? In case we're doing it not on tick. So we don't want to use delta world seconds as like a hard-coded variable. Is it current minus target, or is it target minus target 0? We're 100 units here. Target minus current. Yeah. We also need the accumulated error, which is the accumulated error. Bam. Plus this one multiplied by the delta. That's the new accumulated error. I just realized, how are we going to set current as previous? Because we can't output and then do it. Will that work within a... Yeah, no, that should be fine. That should be fine. Oh, well... Do I need to cache it? Oh, okay, no, I can cache previous error as a local variable. Temp rev error. So this gets cached just at the very start, because we're then gonna like set previous error as current error after we've done some calculations. Do I need to cache this, or do I just need to cache the result? Yeah, no. I just need to cache the result here, then set this, then set the cached result as the return. Yeah. Okay, so we've got accumulated error. We then need the error minus previous error. Or is it the other way around? How did I do this in my other dude? Current minus previous divided by delta. That's coming from our function input. Tried Unreal Angel script. I have not. So this is our derivative. Bam. We then sum them. So we get our accumulated error multiplied by our integral factor. We get the error, current error, multiplied by the proportional factor. And then we get the derivative multiplied by our derivative factor. Nice. Trying with velocity PID. I'm making a generic PID. So velocity and torque PID. I can show you what we're trying to do. You can probably see already what we're trying to do. Obviously, this is not set up now. I have the prototype here, which I can just replace. Instead of PCMS, I can go PPCMS prototype 2. Compile, in it goes. Put a brother there, banger place. It's literally just the entire old school RuneScape MIDI files, just being played through Windows Media Player. Why is this guy angry? Right, because he's expecting this guy, but he should be getting this guy. So yeah, this is the prototype. Just ignore the lack of animations. Also the fucking... Is that just coming from my character? Or is it coming from this guy? Print string. It is. So this is prototype number 2. Why? Okay, that's at least it's not moving. And keep in mind, this is all just torque based. There's no linear like thrusters being used. Also, he's going really slow, but like whatever the fuck. So it does self-stabilize. The linear and angular damping is like really high. Because I'm pretty sure this is just like a PD controller. Or just a P controller. It's like it's a P controller with cheating. You know. PID, not process that. PID is proportional integral derivative controller. So it's kind of just a way to... think of like a car's cruise control, where like you set the cruise control to be 100 kilometers an hour, but then, and let's say you're starting from 0, so the car needs to speed up to get to 100 k's an hour, and then maybe you're cruising at 100 k's an hour and you start going up a slope, so the car has to input more, you know, more doof to go up the hill at 100 kilometers an hour. So it's a way, and yeah, it's like the way that that's controlled. But obviously with a ball bot, you can't just turn torque immediately into velocity. Because with a car, you've got complete stability. Whereas with a ball bot... Yeah, throttle, sorry. With a ball bot, it's like... Yeah, it's a fucking... Let me just pump this up to, like, double so the character goes faster. Yeah, and it prevents overshooting, undershooting, and oscillation. Pew. This is so dumb. But also funny. So the aim here is to have, like, accurate dynamics between, like, characters and the environment. So you can see, like, bumping into one character, you know, I can kind of push them around. If I bump into, like, lots of characters, we kind of just get stuck. Like, we're stuck in the crowd and whatnot. I could do something funny, like, is player control, da-da-da-da-da-da-da. But yeah. Is having the cylinder over the sphere like they're going to cause issues on ledges, like catching the lip of the cylinder in between the sphere? So the sphere is 1 unit smaller than the capsule. But I think I get what you mean, but it's not a big issue because the sphere and the capsule don't... they don't collide with one another. So if I just hit simulate, they're actually like on a spring. There's like suspension and whatnot. But yeah. The way that this looks like with animations, it's like less stupid than it looks, basically. Also, I just want the feet cycling. I don't know. Maybe you go higher. And then you... Stabilizing torque. Generated by... That's on the body. Right, that's like cheating torque. But then we're just adding extra torque here, which is undoing that. I don't know. Okay, why is the character not animating? Did I not? Prototype 2. You can die. Animation. Do all this stuff. Do the thing. Why is it not? Are you... Oh, you're getting the wrong dude? Right, because you're looking for this one. We want prototype 2. Compile. It's going to get angry. You're going to have to get set as... Prototype 2, object reference. Yeah. You go into there. Please don't crash. Go to the anim graph. You are just... is that going to get them right? Maybe it reconnected them via name? Okay, yeah. Oh, but the character's not getting set correctly because I changed the way the fucking sphere... Scaled sphere radius, bam. Okay, this should look normal now. Well, relatively normal. So basically we take the ball's travel distance as like the character's running like stride velocity, you know. So that means if the ball is like skidding, look at this dude. If the ball is skidding because there's like less friction or we're like pushed up against something and, you know, we lose grip, or we're going up a hill and there's something that, you know, like there's like loose pebbles or whatever, then the animation would actually like account for that, which is cool. Try limiting FPS. Yeah, well, so because yeah, it works. Don't worry. It just works. Alright, let's get this stupid little fella doing its thing. Maybe I should one of the Charlie balls. Okay, why are you angry now? Right, because you're looking for this, but you don't exist. Which means that doesn't exist. Let's just get it stabilizing first. Cool. So yeah, he is stabilizing, but obviously it's oscillating. So we're essentially using the destabilization of the capsule to then move our dude. Also, did that scale get changed in the character? Oh, wait, no. Is that because I put the depenetration velocity down? That it's... Which I don't know. Do I like that or not? Anyway. So yeah, we're oscillating, which is not ideal. What we would like to do is... Well, first I need to set up a discrete PID, right? No, that was going to be for the rocks. Actually, you know what? I'll do this first. What was this material called? New material 2. How descriptive. And then I just want to do for each with the index. Multiply by a literal vector. Make vector. Just some like funny numbers, or like funny integerial numbers. Do that, and then truncate. Rounds A to the integer with truncated. No, we want to frac. Can we frac vector? Fuck. Okay, we can trunc vector. What the fuck is that? Oh, int vector. Yeah, that's true, Adam. It also depends on like the sub-stepping in the physics engine and whatnot. But you could kind of say the same for like not physics engine, because like regular character movement gets limited by the frame rate as well. So this is like the cluster. Oh, I need to make these small as well. Scale 0.05. Cool. How much do we want to scatter them? I don't know, 50 units. And then that. So if I put this down, this is like a ball or like cube scatterer. Yeah, okay, cool. They probably need to be smaller. Or smaller? Smaller. Maybe within 100 unit radius. And maybe not in the Z. I do this with low frame rates on my work game. Interesting. I feel like that's just like an inherent issue with just games in general. They kind of just tend to fall apart at low frame rate. Okay, why are they not getting smaller? Was your games based on physics? I mean, you know. No one plays a game at 50. Yeah, exactly. Well, I mean, in like 90% of games, character movement just kind of breaks down at, you know, low frame rates anyway. Why are these not getting smaller? Does that have a hard cutoff or something? 0.0001 scale, world scale. Why can I not make them smaller? Just like, I don't know, set scale? Everything's console still around at lock 30? Yeah, rip. Rip. Okay, so they are small now. We've got to simulate every single... Oh my god, look at them. Every single grain of sand is simulated. You see that mountain over there? It's simulated. You can go there. Okay, cool. So yeah, the cool thing about the ball and capsule movement is going to be that, like, not only can it slip on... Cursed. Can it slip on, like, the physics friction value, but it can actually slip on multiple individual objects and, like, kick it up behind them. Or, like, dead bodies, or, you know, dropped weapons, or all that kind of stuff. So that will be interesting. Where's my PID object? PID object. PPCMS. Play camera, play cursor. Where did it go? Where did I do, like, the base PID thing? Base class, PID tester. Play camera, play cursor. Jahahaha, demo. Heap scatterer. Did I just put it in the content? Okay, search all PID. Using talk to do this? Yes. Yeah. Oh, okay, that was in a different thing altogether. Yeah, so there's no thrusters on the character at all. It's all balancing and that kind of shit. Which means that, yeah, like, characters can trip over, or they can slip over. And when they do, they ragdoll. And when they ragdoll, funny things happen. Right, where'd that object go? Here it is. PrisMatic controller. Update PID. Get the current error. Accumulate the error. Calculate the derivative between this error and the past one. Do our three values. Summate them. Summation. We're going to cache this. Summation. That's a local variable. Cool. We summate, and then we set current error as previous error. Cool. And I don't need that. That's gone. Cool. And then that summation goes out here. Bam. Cool. I'm using talk to point towards something. So I'm doing... I do add torque to the capsule. And the reason that I do that is because as humans, we have like a wide contact point to the ground. So we have like our heels and the balls of our feet on the ground. And we can just like lean forward without slipping out and dying, you know? Like if we want to lean forward, we can do it while standing in place. If a real life ball bot wants to, or like a unicyclist, if they want to move forward, they have to first move backwards, then they can move forwards. But humans can just generate torque from their feet. So I'm kind of using that as like a cheat to like cheat stabilize the capsule to some degree, but obviously not overdoing it. Vin, do you think it would be a good idea to do commissions for level design, etc.? Do you mean, would it be a good idea for you to do commissions, like to accept commissions? Or do you mean to commission someone else to do level design for your project? Because I think both of them depend on a million things, basically. We want a initialize. Well, no, we want to... What's this called? Set PID. Values. Which is just going to have 1, 2, 3. This is the proportional factor. These are all floats. Proportional factor. Integral factor. And the derivative. Do you think it's worth... Probably not worth it in this case, but it might be worth for, like, a flying... Like, if you're doing, like, drone programming, right? You might want to have different proportional factors for the Z, up and down, and the XY. But I think in our case, we never really want to do that, unless we start making fucking drones that are physically simulated for some fucked up reason. But I think for now, that would just cause performance shit. So, if we go to our dude... So now that we have a PID set up in its own object, we can then go back to our, you know, whole fucking foot thing. We don't need... Measurement, lean left, feet position, feet previous position. I don't know, yeah. So on begin play, we're going to construct object from class, the PrismaticaDev controller. Bam, bam, bam. We're going to set, well, we're going to cache this. This is going to be the feet PID. Oh. Feet PID. And then we're going to set PID values. These are the initial ones. And then we do this again, but for the body torque. And I don't think we need any others, right? So if we get the feet PID, we say update PID. The target is the stabilization vector. The current is... Well, no, the target is some factor of stabilization vector, right? And the current is the get angular... Not the PID, the feet. The feet, character feet. Oh, we also don't need these all here. Feet error, feet, KD, feet. Got so much fucking feet. What the hell? Character feet collision. Or feet ball. Character football. So character... We need to get angular velocity in degrees. This is the current. The target is whatever the fuck this is. Stabilization vector multiplied by some literal float. Which I think we had like negative 50,000 or some shit. Who fucking knows? So update PID. Output goes into torque. Add torque in degrees to the character feet. And that's our feet done. So this should, if we hit play, the character should just fall over. Because we don't have any values set up. We then go to our feet PID. Proportional factor 1. This will then act like it was just before. Where it, you know, it will stabilize, but it will oscillate very, you know, a lot. Yeah, it's a bit of a fuckfest. Cool. That is expected, by the way. The integral factor is there to, I don't know, do something else. To unfuck it, maybe? I mean, the derivative is there to dampen it, right? So this is like the change in the current, the change in error, right? So this should make it like, okay, maybe not that fast. No, he's still going giga fast. Maybe I'll just put them all at once. Feet PID. PID control. Well, no, actually, okay, so this is just trying to stay underneath the capsule, right? Which it is doing. It is staying under the capsule. But then obviously the capsule, when it stops, is getting yeeted forward because it stops so suddenly. Which then means that it's oscillating. So this is where the inner-outer, like the double PID, comes into effect. And that is that we want the integral predicts future torque. No, so the integral will accumulate error over time. I had like a thing set up here, PID tester, where like this is just a ball that's trying to reach this like this ball here. So if we have proportional set at 10, derivative set at 2, but integral set at 0, the integral is there. So this ball's being affected by gravity, right? Yeah. Because the error, so like, you know, this is like a few hundred units down, can never overcome the gravity. So what the integral does is, you can see on the side here with the print strings, it accumulates the error over time and then uses that to overcome the thing. So if I set that to 1, then it will fall down, but then it will slowly reach up here over like a very long time because it's a very low value. But yeah, as well as to predict the future output. That's the derivative. So the derivative is the current error, so the current distance and whatnot, and then the minus the previous error. That gives us the, like, the slope of the, you know, the curve. Which, yeah, we can then use to, like, slow down or speed up, depending on, if we're like going the right way. So if we're accelerating away from it, it will move it back quicker. And if we're moving so close to it that we're going to overshoot it, it will slow itself down. Yeah, Elliot, how's it going? Welcome, welcome. Float history for this main. Yeah, that's true. That's true. I could definitely do with some graphing. So yeah, this will stabilize at its intended point, basically. Look at these dudes. Look at these dumb ball bots. So if we wanted the... Let's get the body PID, right? And we're going to update it. We should probably update the body first. Well, no, it doesn't actually matter, does it? Let's do a sequence. Well, so this would be parallel ones. They're not actually talking to each other. Anyway, update PID. This is going to get the target velocity and turn that into a desired torque. Kind of. Let's go to the old prototype. At talking degrees, target velocity crossed with the current up vector. And then an acceleration value. And then this was doing some shit. Distance between target velocity and the actual walking velocity, but yeah. We're doing totally physics-based movement? Yes. Yeah. Because it's funny. You know? And then the current is... What is the current? I guess it's just get current velocity. So body... Get velocity. Or get... Oh, that's the PID. We need the body... Character. Character body. Get linear. Physics velocity. Bam. Cross that with the current up vector. But that's not really what we want to do, is it? I think we want to do it more like target velocity. Bam. Current velocity. Bam. Oh, the delta time. Delta world seconds. Oops. I didn't factor that in before. Then we want to cross the output with the current up vector and whatever the maximum torque is here. And then apply that torque to the character body. Yeah, so actually in this case, get physics angular velocity in degrees. We want to get the stabilization vector, convert that into... Oh, fuck, how do we... Current target. Do you know what I mean? It's when it comes to 2 a.m. seeing you streaming, yeah, it's, I'm a very late streamer. Right, target velocity should always be 0. So these guys are all going to try and stop. They're going to just try and sit there and do nothing. Which they are not doing. For some reason. Hello? They should be trying to stop. Why are they not stopping? Okay, physics linear velocity. Is it just that this is the wrong way? Ah, no, because we didn't fucking set our PID values on the body. Base class, here. Here. PID values, proportional, just fucking 111, whatever. Just see how it goes. Just do your thing. And what the fuck are they doing? Very interesting. Huh. Huh, okay. Maybe that's just like 1 or something. Okay, they just fucking died. Velocity... Oh, no, because we're turning velocity into torque, right? So the target velocity is 0, and then their current velocity is something. This needs to be an XY target only. So I put that into there. Crossed with the current up vector multiplied by a acceleration amount. Let's just like, yeah, put these down very far. It honestly might just, yeah. Let's see. Okay, so they're not... they are spinning. They are all moving. Fantastic. So if this was a greater proportional factor... No, but that's just going to say, like, do the thing quicker. So that was 1. If the torque was greater on the body, so the body has more authority. Why does it... So taking an angular acceleration instead of physical torque, i.e. mass will have no effect. Is that's in degrees, not... Oh, target velocity, current. Yeah, so we're like getting giga high values, converting them straight into torque. Okay, they're less stupid. 10? Is this supposed to be a negative value? I feel like it's going in the wrong. Yeah, there we go. Okay. So now if this guy yeets across, he will bend back this way to try and fix himself. But that needs to be a bit slower. Or have less torque. Maybe that's just too powerful. So now you go this way. And you want to be at 0 degrees. Sorry, go simulate. Hit you that way. Okay, there we go. Yeah. So he gets yeeted. And then, okay, he flips himself back that way, but friction's getting a bit fuck-eyed. Okay, yeah, he stabilizes himself. And then there's a bit of overshoot. So that's where the integral and the derivative come in. And so now, oh god, that looks a bit terrifying. They all look like they're about to like... Okay, so we're generating yaw for some reason. Why would we be getting yaw? Oh, because in here we're getting stabilization vector crossed with the up. Get angular velocity in degrees. Output torque. Let's just zero out the Z component. Yeah, there we go. Oh no, they're still fucky. So is that because... Is this just too powerful? Or is it because these values are just silly? I mean, yeah, they are. Just go with that for now. Alright, they're stable. If he goes this way, he does try and slow down. But he overshoots it because he's dumb as hell. Which means that the proportional is too high, or just this value is just too high. What's like the maximum thing? I'm pretty sure I want to do like a nested PID. So like the... Yeah, let me just do this so it's less fast. And we'll keep the damping up pretty high. Wrong button. Okay, why is he so fucking fast? Less damping? For the body? It is the body, right? Yeah, I think it's just that the ball can't keep up with the body. Add torque in degrees. That's only at 10,000. If I put that to like 5,000, is that going to be a bit better? Or is it just going to skits out? Alright, well, they are stable. Oops. Yeah, so the the body isn't talking hard enough now. Oops. Okay, here we go. It's stabilized. If we move it, then it will try and unfuck itself. We're still getting some, like, yaw slip. It is world space yaw. Oops, okay, they're in pain. Let's get the feet and break out the Z and just multiply that by -1 and just fucking add that as force. Just so it doesn't... doesn't spin out like that. New velocity in degrees. Still have default physical material on your ball. I've changed it. I've changed it to a, like, 100%, 100%, what do you call it? Friction. Just so we can, like, not worry about friction. Yo, Mags! Hello, hello! How's everyone doing? Welcome, welcome, welcome! You've joined at just the right time. And by right time, I mean I've no idea what's going on. I'm basically just creating human bowling pins at this point. Oh. Hello, hello, hello. Welcome. How was the stream? What were you working on? Niggas are usually... Oh, hell yeah. Nice, nice. I'm currently working on I'm basically building, like, little robots in Unreal to then act like characters. Which kind of sounds dumb, because, like, it kind of is dumb. But it's funny. That's what it is. What is I'm trying to inspire skyscrapers today? Ooh, nice. Oh, PCG. True, true. Yeah, PCG's crazy. I haven't looked into it heaps yet, but I'll definitely be using it. So I'll probably be asking you questions about it. Oh, okay. Oh god. Okay, no, they are stabilizing. That's good. And he will lean back to stabilize. Okay, good. But he's never going to go back to 0. You get into lean, and then you want that to know their movements. Oh, sorry. Was there a cat cam? There is a cat, actually. Hey, laddie. Oh, no, it's good. Oh, my God. Sit on you. Yeah. You'll be right. Very good. There was another cat in here earlier. This is the smallest of the cats. I don't know where Lady Cat went. Lady Cat's the big chonker. You can just sit there, girl. Lay down. Sit. You want to sit on me? Okay. That's fine too. That's fine too. How many cats do you have? Like 3.5. One of them's like a stray, or like a wild cat, basically. Not like a wild cat, one word, but like he's like a... He's not feral, he's just, I don't know. They're all farm cats. So they're all like 80% outdoor, 20% indoor. But this one's an 100% outdoor cat. Like the other one. His name is Mr. Cat. This one's name's Girl Cat. The big one is Lady Cat, and then there's another boy called Boy Cat. Inspiring, exactly. See, I'm glad you guys get it. Okay, so by adding the integral, maybe less integral, more derivative. It's hard to like tune these together. Because it's like we're converting an angle. It's like for a character and another character. Let's get them. Sorry. Let me explain what I'm trying to do for the people in the back. So essentially, with Unreal Engine, something that happens is that the characters... there's an ad playing, apparently. Give me 30 seconds. We'll figure this out. Okay, they need to, like, stop doing that, basically. Head torque in degrees. This is for the body. And then let's just get the target velocity, current velocity. Add torque. That gets zeroed. Let's get the output here. No, that's linear. We want to get the angular. Get angular. In degrees, let's just get the Z of you and add you to here. As a negative. Sorry, multiply. Bam, that should just stabilize them to some degree in the yaw. Okay, so what we are trying to do, or what's the problem that we're trying to solve? So in Unreal, with the default character movement, or just character movement in general, if you're using kinematic character movement, characters don't collide with one another, like they do in our example. And they also don't collide with physics objects properly. They kind of like fake it, but it's just a bit annoying. So my solution... Characters also don't, like, interact with friction correctly either. So, like, if they're going up a slope, or if the floor's made of ice, there's no way to tell if they're slipping, or if they're moving, or what their intended velocity is, all that kind of stuff. So, in essence, what we've done is we've moved it all to the physics engine, which is a lot more chaotic, but also a lot more fun. And it also ends up being more performant than doing it, you know, like manual character movement. Because we're just supplying, oh, what are the forces we need to add in the next frame? And then it will just yeet it all so it all works. So what we're trying to do is to actually make characters balance on their feet. Now, this is a bit hard. So I've looked into like a lot of robotics theory. And we came across PID controllers, which are... It's essentially what like drones use, and also cruise control, also like oven temperature sensors and whatnot. We use PID, which is proportional integral derivative. And we're just trying to, you know, figure it out. What's making them fall over in the first place? That's called gravity. Gravity is making them fall over. So if I like plop him like this, bam. So they don't cheat. They don't just stabilize using magic. They actually physically like simulate at all times. So like if I tilt this guy, he's gonna like, you know, move this direction. If I like nudge him, he's gonna like lean back the other way to stabilize. In theory, if I wanted... Yeah, so there's no locked rotation, exactly. We just rely... They look so cursed. Let me just fix the animation blueprint. Why do they look so dumb? Base close, yep. If I do that, this should all succeed. Should be able to quit. And then if I simulate, do they animate, or did I... No, I unhooked that. That's also a bit... No, it's not too bad. We can deal with a bit of foot in ground. The animation, if I go to the base class here, let me hook up the animation stuff, which is down here. Bam. This should work in theory. If I move you along. Yeah, okay. There we go. Okay, so characters work now. They actually, like, step. It makes a lot more sense when you see the character animated along with it, you know? Obviously, we can't see it fully. I might just dither this. Let's just get a dither. And alpha, I don't know, 0.5. Chuck that into the mask. And mask. Is that going to do... No, that will do just these. Oh, but the character uses the same. Oh, God. Duplicate. Number 3 is for the character body. And you don't dither. Very good. Let's go to... test character. We go to the scaling mesh. Material... Oh. Oi. Material 3. New material 3. There you are. So cursed. Okay, so now we can see the capsule and stuff, but we can also see the characters ghostly in there. That's way too undithered. Does that work? Okay, that's fine. There'll be a bit of weird ghosting, but that's fine. They also don't... Okay, let's just do forward and back so that animation doesn't... Oh, okay. He's not looking too good. No, why are you on your side? I'm just so confused. This is the worst stream ever. Gosh. Okay, character. Give me another character to just boop him around with. So yeah, characters, we want them to be able to like stabilize and be affected, like to rotate, and for that to be actually like physical. A lot of the game is like traversal and also like combat. So being able to push characters around or restrain characters with like ropes or like grappling hooks and all that kind of stuff. So if you had, let's say you had like a, I don't know, like a grappling crossbow or something, some fantasy thingo, and a character was running away from you. Well, like as an example, if a character is stationary and you shoot a grappling arrow and it wraps around them, it's not really going to do anything other than like, you know, disallow them from getting far away from you. But if they were already running... So imagine this guy's running away. He's running away, but then, you know, we grapple his feet. He would lean forward and, like, probably eat shit. Or if you grappled his head, he'd get yanked backwards. And if they get yanked hard enough, if they pass the threshold of probably like 45 degrees, I think, is reasonable, then they'll just ragdoll and turn into like an active ragdoll and flail around, kind of like the new Grand Theft Auto games and whatnot. Reminds me of Exanima. Yeah, so in Exanima, characters can trip over and whatnot. But then the problem in Exanima is the characters don't feel very... They feel sluggish. So my aim is for it to still feel like, you know, regular character movement, but with the perks of being, you know, simulated on the physics engine. So there's like... It ends up being more performant in like a kind of ironic way. You wouldn't think that physically simulating all the character movement would be, thingo. But, yeah. Like I assume you grapple someone, they ragdoll. So, kind of. But, I want character... Imagine like there's, Alright, imagine this. You're like on an adventure. And you see some like slavers with like a chain gang of slaves. Like they're all tied, their hands are all tied, and then they're all tied together. And you're like, man, I want to like set those slaves free because like fuck slavers, you know, fuck slavers, they're all dogs. And so you're on your horse, but then your horse gets spooked and you fall off your horse, and then the horse just like runs between all these characters with their, like, in the rope or the chain, and they all just get, like, yeeted out because they're all attached together. Some of them might fall over, some of them might not. Maybe the horse would fall over. Like, it would just be super chaotic and, like, hilarious. Planning on doing multiplayer? Yes, but it's very... client authoritative. So it's like co-op multiplayer. And all of that, all the physics will just be done using Smooth Sync. Which is like a plugin that just it would look like all the physics is being simulated, but all the physics would be happening on the server, and the client would... Let's say, like, I'm the client. I could push against something, but it would take whatever the ping is for that to start moving on my screen, if that makes sense. But yeah, so that's what I'm trying to do. If anyone has any, like, robotics experience, I would really appreciate, you know, some, what do you call it? Ballball keeps its balance by constant measuring of its pitch angle using a sensor, then counteracts and avoids toppling over by turning motors appropriately. But what is appropriately? Duh. I mean, like, that's the thing, right? We can stop it from falling over. That's the easy part. Like, stopping it falling over is super easy. If you grapple someone that's moving, they're going to have a huge rubber band if the grapple doesn't let them move. Maybe? Maybe? Seen Overgrowth animation by David Rose? I have seen that one. I don't think it's actually physical, though. I think it still uses, like, traditional character, like, kinematic character movement. Because the ball... I don't know if it has, like, suspension. Yeah. I remember seeing it for the animations and stuff. Moving between the server says they can't move. Time takes to reach a client. All that movement will be rolled back. Yeah, it'll be a little bit weird for the client. Because with Smooth Sync, the clients can have full authority. I'd probably just add a... like a handover when a client gets explicitly, like, you know, grappled or restrained or whatever, so that then their movement would be getting sent through to the server and then thrown back at them. So if they're restrained, then their movement will have, like, input lag, which might not even be that noticeable with, like, how much, you know, acceleration and deceleration and, like, mass the characters have. Like, if it takes 2 seconds to go from walking to full speed, and your ping is, like, even 120, it might not be terrible. Alright, so again, without any... without any capsule stuff, the characters do still stabilize. Because the ball is just keeping up with the capsule. Yeah. I'll be right back. I just need to wee. Alright, I'm back. And I also ate an Oreo. Okay, so we need a better way to, like, this is very very, I don't know, very magic numbery. We're just like, oh yeah, add this much torque, and it's like, well, the fuck does that even mean? We could turn this stabilization vector into degrees, which means that our feet in degrees. Let's get paint. Let's get painting. If we're leaning over, here's our ball man. And our center of gravity is here. Is that what we want to do? Do we just want to move this under the center of gravity? Rather than using some fucking weird-ass shit with the up vector? Because, like, to be stable, this just needs to be under the center of gravity, right? That's way less fucky than using the normalized up vector. So we just let this chase center of gravity, which is a linear distance in XY. And then we can just convert the... Like, because we know how much torque equates to how much distance with the wheel. Yeah, I've watched everything I need to know about PID. It's just about a self-balancing ball bot that I'm struggling with. I think using a position for the ball to stabilize under the dude is... Yeah. Because, like, ball bots exist in real life. Like, they're super simple. Yeah, so maybe that's the first thing we do is just get the feet under the thing. Which gives us a clear indication of, like, okay, yeah, like velocity versus distance, which is like what this is anyway. So yeah, let's go no stabilization vector. I'll keep that there, but it doesn't really matter. Let's go character body. Get center. I can just get its position, right? Just get location. So this is our feet PID. We're not going to worry about the body for now. Let's just get this stabilizing. So literally, character body. Is it our target is the... Is it the location or the velocity that we want to get to the location? I guess it doesn't fucking matter, does it? I guess it is the location, right? Character body is the target. And the current is the... No, but that would presume that we're lerping, right? And this is torque, the output. So So no, we'd want to calculate character body, character feet. Get socket locate, not socket location, just fucking get location. World location. Oh, we actually want world location minus the radius. Scaled radius. Well, no, that's just... Where's the feet sphere radius? Here we go. Because we want the contact point with the ground, not the middle of the sphere. Wait, no, the middle of the sphere... It's the same fucking thing, isn't it? Or like the lowest point? Yeah, no, what am I... It's a fucking sphere. What am I even thinking? So location minus... So target location is the character body. XY, obviously. And then this, we're just going to go XY. No Z. So that's our target velocity. Oh, well, no, we need to convert that to angular velocity, which we can do with my handy function called linear travel to torque. Bam. 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 In vector, this one. Radius, this one. Bam. And then target current. This is just to stabilize the yaw. And so... Well, this is like the target velocity, which is kind of a big... Whatever. Let's do vector max. Oh, no, because the feet need to go as fast as they possibly can, right? So we'll just leave that. Linear travel to torque. Give it the torque. Or do we want to set the torque? Or do we want to set... Do we want to PID the velocity and then convert that to torque? No, because I guess then we want to monitor the torque. Yeah, no, this is better, this is better. So blah, 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 current, this. I think this needs to have a strength value. Angular velocity in degrees. So this is a linear velocity that we want, or some factor of this is a linear velocity in XY. So this is how fast the ball needs to go to get underneath the center of gravity of the dude. Oh, this does need to be the total center of gravity, though. Oh, fucking... Because the ball has center of gravity. So if it was here, then it doesn't need to stabilize as much. But if the center of gravity was at the top, as it leans, it needs to go faster. So it kind of changes what? It kind of just changes the magnitude. So fucking whatever. Bias. So that's torque. Linear travel to torque. Chuck that into the feet PID. And then get angular velocity in degrees. That's the current. And then we chuck that into add torque in degrees. So this should, in theory, just stabilize our dudes. They shouldn't fall over. He fell over. You're dumb. This needs to be big number. Or negative number, I think. Try 5,000. Oh god. Okay, they're all skidding. They are all skidding. That's terrifying. Try 500. Because that's 500 degrees, isn't it? So if you go this way... Okay, you are stabilizing. Like, if I go like this, and I'm like, hey... Hey, fall over. Cool. Oh, yep. You gotta be skidding me? It's funny. Yeah, okay, they stabilize, they stabilize. And then once they're in, like, a constant... he should just keep going and going, right? Well, I guess it's what the fucking balance... Yeah, no, because it's location-based. If you were less crazy... Maybe just fucking 360, you know? Why not? Mm-hmm. Okay, that seems to work. And see, that's good. Once it's at a stable velocity, it's not leaning anymore. Screen out is doing something to get... Yeah, I could try like a linear... sorry, an exponential... Doodad. Doody. Let me just go back to thick capsules. Also, Boom, how's it going? Why haven't you streamed in like a week? I can't remember. I haven't been home for a while. Let's see. Yeah. Okay. You are dumb. There you go. Okay, so this works. And this is getting factored into the PID. That's the thing. The magnitude does have to get factored into the PID, right? It can't just go out here, because then it's like it doesn't really know what's going on. Found some objects, a few don't cull. Any ideas why? It could be that they are foliage instances. So with like instanced objects, they don't individually cull. Sometimes. It might over like a longer period of time, if you like really just like looking this way. Maybe it can like cull them sort of individually, or like choose some to stop rendering. But yeah, I'd say that would be that would be my first order of my first thought would be that they're instances, like foliage instances, or like that kind of thing. Technically, this could... Well, no, as long as the maximum isn't too much. Yeah, so that was trying to stabilize, but it just couldn't. Maybe I'll change how this works. Because, like, yeah, this is the torque. 360 torque. To then get under the dude. But then what I can do is, yeah, adjust the actual... Because that's essentially like the maximum rate. Maximum torque. Whereas this is like, how does it actually behave with that as the thing? That can probably chill a bit. Because, yeah, like, if I do this, if I do, like, really low integral and derivative and only have proportional, then it should oscillate. It should be like, oh, I'm, like, trying to go this way, but then I overshoot it, and then I go back. Yeah, see? Like, yeah, exactly. So then the derivative is there to dampen that so that it actually approaches its midpoint, which we can see. Yep, it's doing its thing. Yep, cool. Oh god, it's so fast. That feels better. So if I like bump a dude. Doink. Oh. Doink. Look at their little feet. Looks good. Yeah. I think that's more natural. Yeah, they can go really fast. A little bit exanimate. Yeah. Exactly. Yeah, okay, that's good. So then all we need to do, now that this is less fucky, feet, exactly. Delicious foot topology. Okay, so what we're doing here is trying to stabilize our dude. We've got the dude. This is our feet torque. Target torque. We then update the PID with the actual angular velocity. This is the target angular velocity. And then we only want to apply that in XY. And we want to zero out the yaw because it kind of goes a bit fucky. So what do you control? Did you get that working nice? Yeah. I isolated them in just like a separate object. Which just has a function called update PID, which is just bam. And then just set the values. So then, rather than having like a million variables in the component, I can just be like, oh yeah, make a PID for the feet ball and make a PID for the body capsule. So now that this works nicely... If someone gets knocked off balance, they'll most likely hard to get upright again. Yeah, exactly. Well, yeah, in like the actual... If I just go to Prismatica maps, the mountain map. Landscape, mountain test map. Just save that. Yeah, just excuse all the nudity. There's just... Anyway, so yeah, if a character falls over, they will yeet, and then they'll get back up, like, as soon as they can. Although I'm gonna add it so that when you're, like, in this active ragdolling state, you can still kind of crawl around until you can get back up. So if you fall over forwards, you'll be able to, like, crawl forwards, or if you fall onto your back, you'll kind of, like, you know, either crawl backwards or try and turn around onto your front. This is all just using the regular capsule movement, which, you know, if I wanted to go up this slope, you have to, like, manually put in, like, how fast you go up slopes and whatever. It's all a bit of a nightmare. But, you know. Vivar's game with stuff in directions. What happens when you need to access a pointer? I don't think in this case it will be, like, that bad. There's only 2 per character. So I wouldn't be too worried about it. And it'll all be going into C++. I might even be able to... I don't know how much manual memory allocation you can do in Unreal, but you could probably allocate the movement component and the sub-objects in the same, like, you know, the same little doodad. I could... you can give structs functions in thingos. In C++. You can give a struct a function. Structs always get stored along with their owner, right? In memory. Whereas an object doesn't necessarily. That would just get added to the heap. I'm going to use mass for the crowds. Because mass implies that they're using the regular... Oh, I mean... If you mean just like a classic get and set position kind of thing, then I might use mass for like the crowd of characters, and then when a collision occurs, swap them into this mode. But yeah. The FMM stack. Right. So you could add the movement component and the objects, the PID controller objects to what's it called? The main reason I need to do it in a separate object is that each PID needs to hold its accumulated error and previous error. Which, like, if I wanted to do something like a character movement controller for, like, a horse, the horse, I'd want the horse to look like a horizontal capsule and 2 balls. A rod and 2 balls, right? And, you know, it's just like, oh, now I have to make, like, you know, all these variables, but, like, 3 times over. And, like, track them all. It's just, I just hate it. I just don't like it. How'd you make the format if you wanted for square or ranks, but stay as individual units? I would do a squad manager that would kind of like how things do formations in like Age of Empires, you know? So all of these guys are assigned to a squad, and then the squad moves, you know, is moving from here to over there. And that squad has a bunch of, like, set positions that these guys will just get assigned to, you know, whichever one they're closest to. You know, some kind of best fit function. So then they'd all move to their, whatever their closest position is. And then they'd just follow that position. So there'd be like an invisible squad guy that's telling them all. Or like, you know, they would know where the squad actor is. Or the squad object. They'd know their own individual offset. And then they'd just follow that. So they could pretty much just be like, oh, here's the squad thing's velocity. I know where it's going. I can, you know, I can go this way and, like, turn as a group. Like that. And yeah, you could do that with, like... And then you could also do things like squads within squads, you know? Or, like, legions within squads. So, you could be like, okay, here's an army manager, and it wants shieldmen at the front, and then spearmen in the, you know, the back line. And so you could then get soldiers to form up, you know, little squads of like, yeah, okay, here's 5 spearmen, and here's blah, blah, blah. And then the army could move. So you could just do, like, hierarchical kind of things like that. And so each character would have its own... Each character would be moving itself, but it would be moving to the position of its squad, and the squad would be moving in the position of the army, and the army would be, you know, the whatever. At least that's how I'd do it. Yeah, exactly. Yeah, so each individual knows their offset from the squad manager, and each squad manager knows its offset from the army manager, and so on, so on. Alright, what were we doing again? We were doing balls. Doing ball man. Okay, so it's stabilizing. Okay. This is getting good. Okay, we're getting there. We're getting there. So now all we need to do is, given a target location in the world, we need to lean our character over. 2 balls and a rod, exactly. Physics angular velocity in degree. Oh, that's just to stop it Z rotating. Yeah, cool. So we just want to lean our character's body over to our velocity. So our velocity is going to be target velocity 0. Or in the case of... So, does this need to... Target velocity 0. This is taking in how to catch up to the dude. So we do this, then we do that. This is looking for... Yeah, a target velocity. Here's its actual velocity. I don't know if I want to do... Do I want to use the foot linear travel as the current velocity? Or do I want to use the actual velocity of the character body? Because I'm just trying to think when we, like, if there's like bumpy terrain or a slope or something, or we lose traction, I guess I can just fucking try either. So velocity, actual velocity, update the PID. This will keep. So we're turning velocity into tilt. Into tilt XY. Crossed with the up vector. Then some torque. So like, we're going from here, and we want to be like, oh, my target velocity is 400 in the X direction. I want to keep leaning, and this will catch up until the velocity is 400. Then if I'm moving and then I want the target velocity to be 0, I'll be leaning over that way, which will then... Target velocity 0. Yeah, no, this should work. This should work. I mean, I can just fuck around, find out, you know. If I just do this, then... Okay, well, they're not dying, which is a good start. If I nudge you. Okay, there we go. It needs more integral to fix drift. Can I set my target velocity yet? No, I need to go back to the player. Character movement input. Do that. Make literal float. Send that to our man. This one. Set target velocity. Bam, bam. You go in there. Oh god. That is a very big value. So our torque is hella fucking big on our this. 10 degrees? Oh, that's acceleration change. Which in... This should take the weight into account, because that then means that a heavier character... Because if you're really heavy, then your torque... of like just your foot stabilization is like less. You know what I'm saying? Okay, well now I'm just not getting anything. Can you just like fucking show me what happens when I do this? Right, the feet catch up really quickly. Cool. If this is not an acceleration change, this needs to be like... How much does our character weigh? I think the top half is 50 kilos. Okay, interesting. Let's just do acceleration change for now. And this is just going to make them flip out, but it'll be funny. Oh my god. Let's take this back down to what, like 5? Or like should the torque... No, the torque should be really low. Okay, there we go. Oh, and okay, we reach max speed and we stop leaning, you know? Oh wait, why are you still going? Oh, that's because the... Okay. Okay. Can I trip myself over? No. Okay, fuck. This is, working? Question mark? Like... And there's like 0 extra damping on like linear and angular damping, which means that the entire thing is actually being resolved properly, which is surprising. That's weird as fuck. Search can install a gyroscope into your characters? A gyroscope... Does a gyroscope just measure tilt? Or does a gyroscope... like a flywheel? Is that what a gyro does? So it like does like it's inside a thing and it's really heavy and it like turns around. Corrects tilt. Okay. Kind of. Stays up for okay. Yeah, so in the body of the character, we're technically gyrating. But that gyroscopic force is representing when we have our feet. Like, we have 2 feet, or 2 legs, and each leg has a foot. And we have 1, 2, 3, 4 points of contact on the ground. So if you stand up, you can just lean over. You know, you can Michael Jackson, Alien Ant Farm, just like lean over. You know? And that's because you've got 4 points of, you've got enough points of contact on the ground that you can just, like, cheat and whatever. Whereas, like, an actual ball bot, or like a unicyclist, right? A unicycle needs to, let's say this is a unicycle. A unicycle needs to move the wheel backwards. It needs to torque backwards to then generate an imbalance, then let gravity pull it downwards and then catch itself up. Whereas humans don't need to do that. We don't need to step backwards in order to start running forwards. Although, if you want to take off really quickly, you do put a foot behind you and kind of duck and move. Like a dash animation, you know? But if you're just, like, taking off normally, then, yeah. Get him to not trip over may actually be something to cheat. I don't actually want to stop them from tripping over. Tripping is actually, like, an intentional mechanic. This is called Jahaha. Why do you not have gravy? Garage is a physics engine? I mean, yeah, I don't know. It makes sense. But good luck controlling it. Yeah, well, yeah, exactly. The other thing... So once this is all stable and, like, good, the other thing is that going up slopes is, like, a whole thing. Or, like, sorry, going up steps. So in the character movement component, it's just like, oh, is the ledge that you're trying to go up on within this height thing? If it is, then just teleport upwards. And it, like, looks dumb, but it feels correct because obviously you've got feet and you can step up onto things, right? In our case, we could teleport the ball upwards. So, like, yeah, we could teleport the ball up, and, you know, because it's obviously on a spring, well, not obviously, but because it's on a spring, Like it's on suspension. If I like start up here and press play, bam, it's on a spring. It would still look natural, you know? The other thing we could do is... Like, yeah, when you can see it kind of fucking up right now. We could, as we get near a step, we could apply an upward, like a fake step-up force that would just push the ball up and give it, you know... So it could essentially, like, climb up a step. And then the other thing... Yeah, so yeah, we could apply an upward force, which is technically cheating. But we can apply a downward force to the contact point, or to where like the foot would be. So it's like they're stepping up on it, and if it is a physical object, it will get, you know what I mean? Sense of the cars that jumps off the impacted potholes. That's the other thing as well, is like, we could just be like, okay, we're moving, and we're doing like some look-ahead traces, and then, bam. Yeah, so collision below a certain point don't affect torque. I thought about doing like a tire. I don't know. It's really hard to make things not affect the physics. Yeah, I don't know. Let's just get this character feeling good. Make sure they feel good. Hey, okay. Now that's funny. That's funny. That's funny. If you try and turn around too fast, you just eat shit. Which is kind of intentional, right? If the ground was slippery. This ground is 100% friction and this ball is 100% friction, so that's unintentional. But if the ground was slippery or your shoes were wet or something, that's something that I'd actually want to happen. Like, I'd want the character to lose traction. What happened to a man running on a ball? Technically, he's not technically, he is the ball. You have no actual physical collision for the feet. So that was an earlier. Let me save these diagrams first. That was an earlier thought I had. Which was, where was that? Here? Yeah, doing a line trace and then manually. So, like, this would have been more of like a hovercraft approach, where the characters hover and, you know, essentially fart really hard so they stay upright. But this way is kind of elegant. So they both have pros and cons. This one makes it way easier to step up onto ledges and for little ledges to not affect, you know, like to not trip them over and whatnot. But doing it on a ball makes friction a lot more realistic. Makes it more akin to actually moving around. And for a game that's like about traversing harsh environments, I think having like a more accurate friction and like footing model is actually like, you know, is good. How to describe your angling control? A man on ball changes his footing to stop or to change direction by simple angle and gravity. Yeah. But feet aren't rubbing against the ground like a ball does. So the ball, if you think about... I mean, you are correct, obviously. But if you think, like... If you're a person... And you're, like, running... But then, like, imagine you've got, like, 100 feet, right? And, you know, eventually this comes around in front, and it, like, goes to here, and it's like that, it's like... Anyway, you end up with, like, this kind of... It's more like this. It's like a weird kind of smiley face. Like that. So if you had 1,000,000 feet, then, like... You're essentially running on a ball. Or, if you stand up right now, and you limit yourself to only taking, like, little inch steps, and just do them really fast, then that's, like, you're essentially a ball. You know what I mean? Now, obviously, you know... It's a choice between a hovercraft, which can't really model friction. It's like trying to model friction on, like, a drone, you know? Or we go, like, full-on model both feet and, like, the fulcrum point of each feet, and then do completely procedural animations, which can work, but... It's just ridiculously hard to... Like, you see, like, Boston Dynamics are, like, you know, still trying to figure that out, and they've got, like, billions of dollars of funding and whatever. I want friction in a way that isn't realistic is all I'm saying. Well, it's more realistic than not having it at all, you know? Like, if we accelerate really fast in real life, and then go back the other way, but there isn't enough friction, then we would fall over backwards. Or, if we're going up a slope, and that slope has, like, a bunch of little rocks on it, like, if we put this under it, and then put you under there. And then get a ball spawner. Do I still have the ball spawner? Oh, sorry, the cube... or the scatterer. Cube scatterer. Hello. So yeah, if we did something like this, then, okay, obviously minus the tripping over and whatever. Any other, like, method of doing the character would just, like... Obviously, once this has, like, proper... I mean, maybe if I just make them smaller, it'll be more obvious. But yeah, we can essentially do... Instead of just, like, rigid body friction, you know, oh, this has a friction coefficient, blah, 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 blah. We can essentially model, like, tripping over on marbles, you know? Because even if marbles are made of rubber with 100% friction coefficient, you can still slip over on them. And so this would be handy for, like, walking over you know, dead bodies, or like heaps of arrows, or like, you know, logs of wood that are like, and you're fucking like, you know, running across these logs of wood and shit. It's like kind of crazy. So this is like, again, it's an approximation, but it delivers a few like really handy properties, which is we can directly translate the rotation of the ball to the stride of the character. And then if the rotation of the ball doesn't match the velocity, like the actual movement of the ball, then we know that the character is like slipping or tripping over, and we can animate that, which is really handy. So like if we're on ice, then this will be like spinning out further or like faster, but so our feet will keep moving, but it won't necessarily, it'll look like we're slipping and sliding around, which again is something that you'd have to add on top of the Unreal movement system, which is annoying. So yeah, I think this is a good solution. Maybe questioning what this would do for a one-legged character. Oh, fuck. For a one-legged character, you'd just do the same thing, but they'd move slower and you'd animate them with one leg, you know? I could make this character limp, actually. Can I do, like, Loco Limp? Limp L. I don't know if I have running limp animations. I think they only go up to 150 thingers, but if I go to our player and I say target velocity 150, hit play. Yeah, he's still chilling. So yeah, you could do this for a one-legged character. How are you going to handle the direction character's facing? It depends on the facing mode that I set up. So, by default, the character will try and face their intended velocity direction. The yaw will be controlled by the PID, because your facing direction can actually be like if I nudge this guy, it will rotate me around. Or if I don't know, if I'm running really fast and I like clip myself on a wall, then that will kind of spin me out and whatnot. So the yaw has to be like physically simulated as well, which is funny. Yep. But I'm not going to worry about that right now. I kind of just want to do making them not trip over so hard. So like going up that without heaps of... So it needs to what? It needs to really rapidly... Cast for steps with downward sphere trace, apply upwards force to the character to reach that height. Yes. Yeah, for stepping up. Yeah, like that. I mean, it'll just keep doing an upwards force until they don't need the upwards force anymore. And then we'll also apply an upwards force to... sorry, a downward force to whatever they're, like, stepping up on. If it's physically simulated, obviously. But small bumps like that... maybe... Yeah, no, you know what? Maybe we'll add that in first and then tune the other stuff around it. But, like, in theory, the target torque... too top-heavy? Yeah... Can we do get owner and do get center? No, we can't. We'd have to manually do it. Tune stuff now might need changing later. So yeah, that's true. That's true. Well, I just want to see if it's possible to get up that without tripping as much, you know? Because, yeah, that's a very small ledge. And, like, tripping on that is kind of, like, depressing, you know? So, what needs to be tuned? In here. I also think the... let me just go back to the velocity. Let's go 400 units. Oh, one thing I haven't tried, actually, which might be worth trying, is giving the feet 0 mass. Obviously, they're still bound to the scaly mesh with a spring. But if they have 0 mass, then they should be able to ride up things. Or very little, close to 0 mass, I guess. And then I'd just give the body extra mass, 60 kilos. Yeah, I agree, Core. That's something I'll do. Okay, well now that... Why is that not springing? If it... Okay, maybe it needs some mass, but just not that much. Let's give you 10. 10 and 60. It is using acceleration change, which does affect... yeah, stuff. So cursed. Alright, let's just put that back to 15 and 45 for now. That's the other thing is that, yeah, like the... the other way around? Maybe, but... I don't know. Let me just change this to... I don't know if it's this or this value. Like the max torque of the body. That's the issue. Yeah, I forgot that he's, like, limping. So this looks better, but... oh yeah, because it's proportional to the... Oh, and it can overshoot. This can overshoot. But, like, I like the responsiveness of this one. But I feel like it just kind of goes too hard too fast, which means that max torque is fine, but, you know, maybe the proportional needs to go down so that it, like, isn't as fucking fast. Maybe it's this. It shouldn't really need to lerp. It should... That's kind of what the PID does. It's just like a fancy lerp. It's a lerp with a bit of brain. Why would it be going back like that? Is that because the integral is too high? Or not high enough? Or, like, does the integral... If the integral was really high, right? Let's just put this up and put this up. Let's just go back to where we were. Because, like, what we'd want to do is be like, oh, like, you're doing this. Yeah, or you could see it there. The integral starts kicking in, where it's like, oh, hey, shit, we should, like, fucking be, you know, up here. Do we want a... Well, because this is saying... Like, when this trip happens, right? When we trip... Go back. We'd want this to tilt forward, but what? I guess if our velocity is zero, yeah, okay. So if this integral was way higher, so the integral is like, fuck, how do I even explain it? It's like we're trying to go this speed, but we haven't been going this speed for, like, a while. And so it will, like, fucking just speed it up. You could kind of see it there. And now it's going to backpedal because it will overshoot because I've tuned it way too high. But you can see... Okay, well, let's just see if it works when I, like, start tripping over. Oh, see there, right? So when I started tripping, it was like, hey, I don't want to be moving. And the longer it's moving when we're trying not to move... See, like, I don't have my hands on the keyboard, right? It's like, oh, and it's like, fixes itself. Because, yeah, because it's essentially saying... I'm moving when I shouldn't be moving, and I have been for this amount of time, because it accumulates the error over time. And so then it's like, shit, I should, like, really be tilting the other way to counteract the velocity. I could try, like, a, okay, that failed, obviously. I could try a, But yeah, see, it's overshooting again now. I could try a fucking... Oh, God. Terrifying. What was I going to say? I could try a non-linear integral accumulation? Question mark? Like, how would that work with the delta, though? Do you know what I mean? Or, sorry, we'd use a... accumulated error integral factor. That's not even how you spell in... Wait, is it? Integral? No, it's integral. Yeah. Function of which a given function is the derivative. Blah, 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 blah. Yeah. Integ. Why'd I put an extra R in there? I spelled it right here. And there. Treat the delta between the positions as the current velocity to ignore the error completely. Treat the delta between positions as the current velocity to ignore error completely. Well, that would assume that we could apply infinite force to the character. Which we can, obviously. We can just set the position if we wanted to. But we want to give the character limited ability. And then for them to fail, pretty much. What's physical material on the ball? Maybe it needs better friction. It's got 100% friction. It's kind of the fact that it's on a spring. So if it like rotates fast enough, it might not touch the ground. I'm pretty sure I set it back to Vismat. New physical material. Yeah, 100% friction. Which is maybe not a good thing. Maybe the 100% friction is causing it to lose traction. Because it's getting stuck and then jerking upwards with the suspension. So this is 80% friction. Which, yeah, it does spin, but... yeah, it's just if we're moving super slow. Well, yeah, there you saw the friction didn't help us there. Maybe that plus some upward... whatchamacallit? Like an upward helper, you know? As long as the controller knows the character's not moving when it's stuck on something. Yeah. Well, that's what the integral is supposed to help fix. Then we have to deal with, like, traction control and stuff. Because, yeah, if you were, like, moving and then you started slipping, you'd stop doing your running motion and reassess. That's essentially what our traction control is going to do. Yeah, the integral does cause a lot of fuckery. I wish that Unreal had soft collisions, like, built in. Or, like, semi-collision. Maybe I'll put that down again and just... Okay, that's way overstepping. Yeah, I don't know. Maybe it is just a matter of doing... Yeah, it does have... Yeah, exactly. It does have collision detection. Yeah, so yeah, this looks like, minus the obvious stupid animations and stuff, this actually looks like, yeah, the character is stopping and then moving, you know, doing their thing. Like, it looks real, which is cool. Obviously, we need them to face the right way if they're running. When they're moving, there's no real issues with, you know, little bumps. It's just when you're, like, going slow and you then hit a thing and it's like, you know, it'll then spin out. Doesn't actually, we're building a physical character movement system using balls. What is it to step out? F9? No, that's... Oh, fuck's sake. No, why does F... Is F9 screen capture or something? F9... Oh, no. Oh, no. Okay, we're good. Catapult. Oh god, they're all tripping. Terrifying. Like the idea of a robot that doesn't bother facing the way it's running. Yeah, I mean it's called a ball bot. Literally what these are. Look, a bunch of ball bots carrying a thing. All together. They get squished. Does the character not... Oh, why does it not squish? Where am I calculating the... the thing? Fully humanoid. Right. Where is the... Ah, right, that's what I was doing. This. That was the initial height. Hey, let me see your little booger eye. Funny girl. What's wrong? You got a sore eye. Come here. Doesn't want to sit. Suspension amount, distance between this and that. I can just hard code it for now. Fuck it. What's the initial height? You know what? I'll just do this at the start. Yeah, so the suspension is for the characters when they, like, get squished down. Wait, does that... What the fuck? Why do you not... Oh, suspension amount. Set root mesh location. Sphere scaled radius. Do that. Da, 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 da. Do I need to... No, surely not. Nah, fuck it. Anyway, the visuals don't matter. Games aren't about visuals, you know? The first game mount, yeah. That's what this is. So we can get microtransactions. Balls pandemonium. Yeah. That is it. Does this reach 400 units speed? That looks like how fast our characters normally go. Cool. Right, I wanted to test, like, slopes and stuff. And we may as well make the slopes physical. And or seesaws. Oops. Use Chaos Vehicle wheels, they work great for slopes. True. The Chaos Vehicle wheels have... Do they do, like, tire deform? Or, like, can you have, like, hard and soft tires in the Chaos wheels? Can make the ball larger. So that's... I know that the problem is that you then run into issues of characters tripping over each other's balls, and also like the feet then collide with like walls and stuff before the body does. And it just causes like tripping and like weird kind of things. I did think of that, and like, yeah, it does work way better, but then it kind of falls apart for the same reason that, yeah, the ball is bigger. I think doing a bit of like hovering is gonna be the solution. Or like helping it get up ledges will be needed. Also, why is this guy not staying put on a slope? Well, that's the other thing, right? Is that, like, yeah, the character can just, like, stop. Well, in theory, they would fucking... Oh, because the integral. You idiot. I turned the integral all the way down. On the dude. That's what this is supposed to do. Yeah. I'd thought of... I had thought of doing an elliptical ball. Right. So it's an ellipse that like rotates, but every frame we adjust its scaling. So, like, it would rotate like this, but then we'd just be like, how about we teleport you back to this position and set the scaling in the hopes that it would maybe work as, like, a kind of weird, like, upright tank tread? But Unreal doesn't natively do elliptical collision. I could do it with, like, a custom collision object. Or, like... fuck, I don't know. Probably not. The other idea I had was a bigger sphere, but with negative collision, like, here. So it would just be, like, the bottom radius of a sphere. But that wouldn't fix the step-up issue, because it would collide against this point and not be good. So I think just doing a thruster from below would be the choice we go with. Come here. You wanna go outside? You wanna go outside at 5 a.m.? Oh, you're so... Hopping up? Yeah. What? Well, you want to go out? Alright, let me let this damn cat out, and then we will get back to the balls. I also need to take my medication. Goodbye. For a minute. Be right back. Be right back is what I meant to say. You know, I might do a 3-minute ad break. And, like, get some water. I haven't drunk water in, like, what, 5 hours or some shit. We go to the 3-minute ad. Okay, BRB. BRB right back. Balls right back. There will be balls. Hey yo, I'm back. Hello, sorry it took so long. I made toast. Well, I mean, I cooked toast. I cooked bread into toast. Oh, it's delicate. Right, balls. So I was buttering the toast, and it just flashed in my mind. I was like, if we're on a slope, then the contact point of the sphere isn't in the center of the sphere. It's offset to the side, therefore it's always going to it's going to trend uphill if we're on a slope. And so, like, you know, if I get this and I'm like, hey, you know what I'm saying? It just came to me in a dream. And by dream, I mean I was buttering toast. But yeah, if I go on here, you can see that our character just goes up the hill. And it's literally just because, I'm pretty sure, the contact point of the feet is slightly off-center. You know what I'm saying? You know what I'm saying, bruh? Alabama, I can't believe you went following. What is wrong with you? Sorry, let me fix this. Thank you. Thank you, thank you. Okay, so. You're essentially either off balance, if not Wall Street. Yeah. So we need to, instead of getting the ball position, ball. Instead of world. Oh yeah. This should be center of mass total. Center of mass with a contact point. So instead of character feet, can we get a... How the fuck do we do a contact point? Well, we'll literally just cast down, right? Well, we do this. We're literally doing this to see if we're on the ground. So let's just fucking get this bad boy. Break. Hit result. The impact point, location of the actual contact point of the trace shape, with the surface of the hit object equal to location in case of an initial overlap. So this... let's... yeah. If it's like directly on the side of the sphere, it's going to get angry. But YOLO. Oh my god. Okay, that was not... Oh, that's the impact normal. What the fuck am I doing? You? Okay. So now if I go up on here, character should... You bitch. Yes. Okay, equilibrium point. Which is like a little bit weird, but... Right, I see what it did there. Right. Because it was like... It was trying to step up, and it's like, oh, fuck, my contact point is over here. I need to compensate by going really fast all of a sudden. Because if my contact point is here, and the center of gravity is over here, then... Wait, what does that mean? Is that correct? Let me just get some, like, non-physically simulated shit. Or just, like, big thing. I have big thing. Welcome to Big Thing. So dumb. Okay, it's a bit too fast, but it's like, it's good, right? Trending my way or into the step. I don't know. I don't know. Alright, this is like a static, non-physical thing. Neither. Hmm. Pretty hard to climb the outline. Yeah, exactly. Oh. Ladder in hard mode. You're not wrong. Try addressing the restitution. The more rugby ball may assist. A more rubbery ball may assist. Do you mean like bouncing? This, I think this has 0 restitution. Let me check. Yeah, 0. Should I maybe add a bit? It should be able to just, like, it should be able to stabilize on here. I think the integral value is going really fucky. Let me turn integral off. For this. For the leaning man. So yeah, without any integral, it's just always going to drift into infinity, basically. Because it's like, the integral would be like, hey man, like we've been going like not 0 for quite a while. And then it would, you know, drift back to 0. I'm just trying to figure out, like, how... Fucking cat. How can we get it to not do this? Because, yeah, like, the contact point is here. It's not centered. Oh, there's fucking... Alright, be right back. Okay. Sorry, I'm back now. I just have to bop a cat on the head. Have to bop Mr. Cat. There's like cat turf wars going on, you know? Alright, so. How the fuck? What's wrong here? It should be able to... Let me just move character down here first. Let's move you here. So given a really small slope, if you're setting gravity to 0 when grounded, if the gravity was 0, it wouldn't be able to... the traction wouldn't work. Or, like, it would kind of... it would go like this, and it would then rotate like this, and then he would just kind of go up and, like, around like that. I know I can't climb time. Well, okay, so the bump stuff I'm not too worried about right now. What I want is for it to just be able to stay stationary on a slope. Because it's always like... when it's on a slope... No, maybe I do want it to be the center of the ball. Because, like, because as long as the... You know, I think I do want it to be the center of the ball, not the contact point. Because if it's the center and it's like, oh yeah, okay, like here, then it should kind of be up to this guy to like lean it backwards, you know? Because like what's happening when we go on this slope, right? To automatically push upward on the slope to stay in place. Yeah, kind of. Because what's happening here is that... Yeah. Yeah, no, you're 100% right. Like, yeah, when we go this way and we then, like, quickly go back and forth, it isn't, like, it's not perfect. But if we don't overspin the ball, it's pretty much fine. The problem right now that I'm trying to solve is that when there's a slight slope, so see this is like a very small incline. If we go on it, our character just is moving forward. We obviously want characters to be able to stand still when they're on a slope. You know what I mean? So I don't know why this is doing that. Is it because gravity is causing the ball? Register ball thrust in that direction. So that's what this is doing, right? I mean, maybe I could do it like the negative of the opposite side of the contact point or some shit. You want to stand still on a slope or have them make it heavy? So I want them to, let's say here's our slope, right? Let me go new. Here's our slope here, right? Let's say our character starts on the slope. Which maybe I will do here. Up slightly. So if we do this, bam. And yeah, that makes sense. Like, I can see why it's happening like that. Like, at the start, obviously, yeah, I see. Should this want to stay... No, that's not how this works, right? Like, even then, it's... So yeah, what is happening here is that gravity goes down, the ball will roll back this way. Like, it will roll out from underneath the dude. If the ball had, like... braking, like locking, then the torque from the dude would probably be enough, you know? Should I say they're against gravity? Yeah. Kind of. Actually, so mean player made force and you just stop moving. I mean, I get what you mean, like, when we come to a halt. I mean, okay, let's try that, right? If we just say target velocity. Well, yeah, because we're doing velocity based. Let's just say, okay, at the start, we have an initial location. Initial location vector set by getting the character body, whatever, on begin play. And then we just say target velocity equals initial location, current location. Where the fuck is just this? Yeah, whatever. Initial location, current location. Is it this way? No, it's initial minus the dude. And then just clamp. Max vector. 400. And that's our target velocity. and then current is just get physics. So this will just always point it to that point, right? Its initial velocity. Which there, it's not perfect, but... But it's like, how do you tell where the new stop location is? Will that work everywhere? I don't know. It should be a matter of just, like, applying brakes on the ball. Okay, the friction obviously doesn't allow us to do that very well. That's the other thing, is that should the center of gravity be higher or lower for it to climb? Like, yeah, what's our max? Let me just put the friction up to 100% for a sec. And restitution 0. Can you do negative restitution? Does that make things stick? No, it has a 0 cap. I mean, that's a very steep slope. Maybe that's a bit too much. I have an idea. It's kind of cheating, but it's also not the worst idea. Is to add like a magnet force from the feet to its thing. So I think this is just a dumb starting location. Oh, right, we're doing the target thing. Target velocity, bam. Precision makes things better. Yeah, so I was thinking if it had a negative restitution, then things would, like, stick. Let me try the sticky ball. Or, like, magnetized ball. So, like, whatever our hit... whatever the normal is from sphere trace to this point of the thing. Whatever the normal is, we will add linear... Oh, what's it called? Add force. Not even at location, just, yeah, from center to thing. So, impact, no, not impact normal, the normal. Some multiple of the normal. You know, fucking... This might also solve the bumps, right? Moving a target location, adding forces to the board, so it seems like... Yeah. Well, this might just, like, allow it to grip better. Okay, that's terrifying. Let me just go... Not like that. 5,000's probably too much. Yeah. Oh, no, that's facing the wrong way. Small, we could generate acquired force. Yeah. Okay, so now it's sticking to the ground, right? We're, like, constantly pushing it down onto the ground, which may or may not allow it to go up slopes better. Okay, okay. Yeah, so it means that it's never, like, bounce. I'm, like, manually trying to go backwards now. But, yeah. What if this was, like, really big? It's like extra traction. Which, okay, yeah, you can you can see when they hit one another. They're all fucked up, but, like, YOLO, whatever. Just, oh god, okay. Maybe 50,000's a bit too big. But you can see that, yes, it is maintaining traction. Is friction really maxed out at 0 to 1? You know, that's a good question. I'm pretty sure yes. But fuck, let's test it out. Oh fuck, maybe you're right. Maybe it goes above 1. No, that wouldn't make sense though, would it? Because I think the reason that we lose traction... Okay, you can go high. I figured the reason we were losing traction was because the ball is on a spring. You know, like if I do this, the ball's on a spring on the thing, and it's like kicking itself. It's like kickback, right? But yeah, no, you might be right. Yeah, friction maybe can just straight up go higher. Because, like, that was frictioning, you know? Cursed. Now we can see it doing kickback. Yeah, shit. Okay. Also, would this whole system work better if the center of gravity was higher? Let me just add an offset to the capsule's doodad. Character body, center, set center of mass offset, positive fucking 30, who knows. Does go to infinity? Right, okay. I've always set mine between 0 and 1. More top-heavy? Well, I figured... It's so cursed. I figured being top-heavy makes it easier to balance than being bottom-heavy. It's like if you've got a really long stick and you balance it on your hand, right? Like inverted pendulum. It's easy when it's a bigger stick. Whereas if you have a pencil, you're not able to do that because of the center. Because you know what I mean. So the higher up the center of gravity, the easier it is to thingos. Although in this case, in this case, because we're adding torque directly to this dude, directly to the capsules, then it's more fucked up. Or, like, it's less fucked up, sorry. Rocket pendulum fallacy. Oh, God. It's only true with a fixed point. It's known as rocket pendulum rocket fallacy. Right, right. Okay, well, yeah, it does seem to ironically stabilize better when it's sort of lower down. Both points are free moving, it's the same. I guess the reason it's different in this case, though, is that... Yeah, I don't I'm not a... yeah. It doesn't feel right when it's lower down. Okay, well now we know that friction goes higher than 1. That probably saves a lot of shit. Oh, okay. Throw some training wheels on that bad boy. I mean, honestly, it's not a fucking bad idea. Not a bad shout. Yeah, with more friction, going up little ledges is easier. Like, way easier, because it's like, oh, I'm falling, but, like, the friction can just fucking sort it out for us, you know? Yeah, I don't know. I feel like this should be able to do it without doing, like, a kind of location IK, you know? Also, when the character lands and it, like, kind of, you know, like, oh, okay, not like that, but, like, if they land and they're, like, slightly tilted, and it's like, oh, you know what I mean? It's kind of cool. Why is the sphere not as big as... Like, the sphere has to be less big than the capsule. Otherwise, they, like... I mean, it still can, even. But otherwise, the spheres get caught on walls and do weird shit. Ideally, we don't want the spheres touching things that we're running into. Because then it will try and climb up them when we really don't want them to. And it will also... if we run into a wall, it'll tilt us over, you know what I mean? Is friction extra on slopes or is it constant? It's a constant friction, yeah. I could adjust the friction. I don't know. Like, I feel like the friction that is going to cause skidding is like is from, like, turbulent kickback. In theory, like, in real life, right? If we were, like, running and then did this, we would lean the other way. Do we need to factor in the normal to the dude? As, like, a counter bias? Like, do we need to add a bias for, like, just slopes in general? Because, like, in theory, we should be able to just stand still on a slope, right? Like, hands-free. But because something is causing us to go up the slope. What is it? What's causing us to go up the slope? It's the fact that when we're going up the slope, the ball gets pushed down, which pushes the capsule forward, which then makes our... How are we getting our target velocity? It's velocity... Velocity blah 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 blah. Target velocity crossed with the current up vector gives us add torque in degrees. Do we just want to go with the actual... No, it doesn't make sense. Wait, the current up vector... No, what would that even do, though? We do it with the actual up vector. But that's just going to, like, fuck shit up, right? Is it? No, that seems... Is that it? No. Same issue. It's caused because the ball has friction on the slope, so it tries to roll down. Actually tries to counter and overcorrects. The capsule is... So the way I've got it set up, right, is... There's a target velocity. The capsule will tilt. Like, toward that velocity, and then the ball will catch up, right? So it's like, as a human, we can tilt our whole body, because we have, like, a wide, what's it called? Fulcrum point. Because we have feet. So we can just, like, tilt back and forth and shift our center of mass for back and forth and whatever. We're trying to do character movement using yeah, it's character movement using a ball and capsule that are balancing for movement. Or a ball bot is the actual term. You know, humans is our feet don't roll when we lean. Yeah. But we do have to kind of... We have to grip, and we have to... Well, I mean, I kind of get ya. I get ya. This is Mover 3.0. All games will use ball-based movement in Unreal 6. Hell fucking yeah, they will. I don't think we're adding any extra forces anywhere. Or like, okay, here's the thing, right? If I have an integral factor on the, you know, the velocity stuff, then when I'm on a slope, it will build up integral values and, like, correct itself. I'll go higher. So yeah, when I'm up here and it's like, oh, hey, we should be stationary, right? but you're moving this way, so we're gonna tell it to go back, right? And so, like, now it is kind of stationary. But the problem is that when I release from that slope, it's gonna move back. Like, the integral kind of makes it feel really fucky on the dude. If you print target velocity on a slope, should be 0. No. Yeah. I'll just chuck that there. So if we print, I'll actually give that a key. And we go here, and we say target velocity. You can change the sphere to a cylinder when stationary if it's the root of the problem. I don't think it does. So if I... Oh, this is doing it in all of them. Why am I so dumb? Let's do... owner... locally... Oh, fuck, it has to be a... Can I do... at the start? Player. If player, branch, bam. If true, print. Player's gonna get set on our player. Character player. Begin play. Enable input. Get the dude. Set player to true. Yeah, if it is a wheel when moving, not when stationary as well. No, I think even when stationary, like changing the collision just because it's stationary doesn't like on a slope that like changing it to a capsule isn't going to do anything. It's going to run into the same issue. I could just like set the velocity to 0, but that defeats the purpose of it, you know? Because like, okay, like we could be stationary, like we're not intentionally moving, but what if my thing died? Wow. And we're back. What? And we're back. What the fuck? Alright, look. I think the internet is telling me to give it a little break. Oh. Am I back? Segway's trying to censor the stream. I mean, yeah, kinda. It's just, I want it to be able to do it while I'm not, you know. Or like, I don't know. I would expect, as a player, I'd expect if I'm not touching anything and I'm on a slope, I would expect to either stay there or slide back down the slope slowly. But in this case, we slide up the slope when we're not, you know, when hands are off. Hands free. You know what I mean? What's the other one I had? That's just a linear. Sorry about my internet. I'll probably wrap up in a sec. Overgrade. Yeah. I also need to, instead of the velocity being in world space, it should be velocity, current velocity minus whatever we're on's velocity, you know? So, like, if I just get the when on ground, true, out hit, hit component, get linear. Velocity at point. Point is the impact point. Bam. Bam, bam. Let's call this the floor velocity. Oh. Yeah, sorry, the stream crashed. Yeah. I'll probably wrap up. I feel like it's just gonna keep crashing because my internet's just fucking garbage. Floor velocity. Might do slow calculation anyway, and if the calculation has been exceeded, allow the ball to receive velocity, otherwise velocity based on input. Yeah, like maybe it just needs enough velocity to counteract gravity or something. But I mean, it's what the PID should resolve it, you know? Maybe I just need to put the integral of the ball up, not the dude. Oh, let me do this first. Is the PID causing that? Was that it is, but it might just be tuned incorrectly. Because if you think about I don't know. I need to just look up ballbot. Ballbot on slope. Basically. Let's go target velocity. Da-da-da. What was I trying to do again? You can fuck off. Well, no, that was for the target. What was this doing? Get world location, get character feet location. Da-da-da-da-da. So this should be... I'm so confused. Target velocity... I think the ball needs braking, right? Like, yeah, what the fuck am I doing? Yeah, no, I think the ball just needs resistance. Do you know what I mean? Not mass, but just resistance. Because, like, in this case, we'd expect the character to be kind of pulled around by the platform, and they would, you know, they'd adjust their thingo, their the rest of their body to, like, compensate, you know? Like, yeah, I feel like if we're trying not to go anywhere, the ball needs to just, like, shut the fuck up and just do its job, you know? And, like, stick. Not like inertia, but like... Because, yeah, like, okay, let's say we're on, like, a train. Or a tram or something. And the tram just, like, accelerates. Whoa! We'd get, like, moved along with it. And it would move our feet out from under us. Oh, I'm not touching anything right now. But we're just saying... We're creating counterforces. Yeah, like the integral part should be creating counterforces. The reason using a Q when I stop moving is a bad solution is, like, we do want the character's feet to get kind of pulled out from under them. But then we also want them to have some... You know, like, if you're in a tram and you're not stabilized very well, then... You know, your feet get pulled out from under you, and you might take a step to compensate. But then after that, you're like, you know, you've kind of... you've stabilized. I think the problem is that the capsule is determining... Like... All the ball is trying to do is stay underneath the capsule's center of gravity, right? Can you do braking on a... Yeah, maybe. I don't know. It shouldn't really matter, because, like, if I locked the ball, right? Well, okay, if I just, like, get the angular damping of the ball and set that to, like, fucking 10. So it's kind of like it's moving through honey, right? It's rotating through honey. You're driving with the physics constraint? No, I'm not, actually. I'm driving it with just add force, add rotation. I can add, like, set max angular velocity. Then we should counteract the force for the transable, should be not automatically. As like the player. Well, wait, what did I just do? What did I set differently again? Oh, the damping. Right, it's just terrible. It's just not being allowed to, like, do anything. But yeah, if it had damping, then it would like get moved by this more, right? Do you know what I mean? Like, I'm not touching it. And so in that example, yeah, it was kind of pulling and pushing us around more. If I, like, up the damping and then increased the balls, you know, just, like, fucking double or triple the whatever, the force that it could do. I don't know. I don't like how that feels now. Obviously, I'd need to retune it, but... Can you use the demo when the player input is 0? Yeah? But it also feels hacky. Like... We should be able to, in theory, just self-balance. In theory. In theory XD. I can obviously add manual braking, right? Like, I can just get the current... Like, as an example, here's our feet stuff. Literally just get... Oh, no, that's body stuff. Yep. Or, you know what I could do, just for fun? Set angular physics velocity in degrees 0. You know, bam. Now it's locked. Locked AF. Can't do anything, right? I could... As like a really hard braking, get angular velocity in degrees, set velocity in degrees as, you know, a... right? Sorry, my stream keeps crashing. I don't know what's wrong with the internet this early in the morning. Okay, that's terrifying, but... Don't you only lock the balls torque? Well, yeah, that's what I was doing just then. It just collapses. Like if I just set it to... Well, I don't know. Maybe there's two... I think that's the KP and KD value. Yeah. Is there an upper limit to the torque applied to the ball? Technically, no. I'll implement one so that, like... Is it straight proportional to the angle difference? There's this number here. Which is just getting the location of the ball, the location of the center of gravity, and trying to put the ball under the center of gravity. That's it. That's how the ball works. And then the body just tilts. It torques itself. Also, this is with a locked ball. Like, with a locked ball, we can still stabilize using the thing. Students prevails once they have a sane torque limit on. I don't know. I feel like it's... I feel like, yeah, maybe braking and moving need two different, like, modes. So when we're moving, the... Oh, fuck, maybe that's it. When we're when we have target velocity greater than 0, wonder with the easy mode way parent the player to the moving platform. That wouldn't work because we're simulating physics. Which is kind of the whole point. No, so what I was saying is, if we have two modes, one is traversing, one is braking, right? When we're traversing, we're torquing the capsule and the ball does the stabilizing, right? But when we are stationary, we want the ball to be stationary, if possible, and for the capsule to do the stabilizing. Does that make sense? Yeah, exactly. Because then if we're trying to stay still and the thing moves out from underneath us, like, we want to move along with that. If we're standing on a train and the train moves, we want to move with the train. We don't want to, like, slide along the entire fucking carriage. We want to stay in that, you know, position. We're braking. And so when we're braking, we want the ball to be stationary, or our feet to remain planted, but we use the torque that we can generate from our feet to stabilize ourselves. But when we're running, we're using the motion of our feet to catch ourselves as we run. So maybe that makes more sense. To have 2 drive modes. Because, like, the thing is, right, with these slopes... If I can fucking find... Oh, I guess this is a slope, right? With the slopes, when we're moving up the slope, or, like, when we're moving on the slope... aside from that, which is kind of dumb. Maybe we do need a slight counteraction on the slope. Different torque max the torque means depending on player input length 0 max torque. Yeah, but I'd need to tell the capsule to like compensate, you know. But yeah, like if I was just standing here, what I want to happen is for the ball to lock and for this guy to, you know, to do the stabilizing. Why is it sliding now? The thing is though, as soon as I get off this, then the integral is like not catching up. The troops, yeah, it's funny. Yeah, like the ball should be able to make it up this slope, which it does, obviously, with enough friction. And it should be able to just stay stationary. So yeah, maybe it's a behavioral thing. Now, because there's like weird vibrations, it's like... Yeah. Let me try the sticky thing again. The other thing I could do with the, I could apply the floor velocity to... Maybe only an XY. Well, no, I guess gravity would fucking... Add force. I mean, this is obviously not going to help with the slope, but the... Wait, where do we start? We're over here. Just plop him down. No, it's not doing it. I mean, maybe not. Fuck. Anyway, I don't know. My internet just keeps fucking. I don't know if it's OBS or if it's my internet. I think it's just OBS. Maybe I need to update OBS. But anyway, I'm going to wrap up the stream. Thanks everyone for hanging out. I appreciate all the help. I appreciate all the help very muchly. I might do a bit more research on this one. Just like see other examples and whatnot about like ball bots on slopes. But yeah, it's an interesting one. It has a lot to do with like the integral part of the PID, right? Because like if you were saying to a cruise control unit, maintain zero velocity, but you're on a hill and it starts rolling backwards, the integral would accumulate, and then it would push itself up the hill because the error would accumulate over time, and it would then be like, oh, we need to like do this thing, and that would, and like that's kind of, I don't fucking know. Just want to know, how's the character animated? Is blend space or something like that? Is procedural animation? So the character's just animated with a blend space that is using the. Let me just plop them down and go back to the scene. It's just a blend space. Let me turn it 90 degrees for you. Animated using, yeah, just a blend space. And it's using the rotation speed of the ball converted to linear, you know, radial to linear. Or angular to linear. To determine, like, the animation speed and all that kind of stuff. Car would have a brake to engage for that situation? Well, no, you could apply acceleration to at a constant amount to make it steady on a hill, you know? Without needing to, like, brake. But yeah, I mean, humans can brake. They can use brakes. This is something for the game or just a little experience? This is for the game, yeah. It's all to do with the way that characters interact with one another in Unreal Engine. Or don't interact with one another. Or interact with, like, physical objects. Or don't interact with physical objects. So this is just, like, a nice way to have, like, two-way interaction. Also, yeah, the bitrate's really low. Just, my internet's just going to fucking absolute shit this morning. But, yeah, Australia is going wrong with the bitrate. But yeah, so the idea is, like, characters can, like, push things around. Ignore that guy, he's fallen over. We can push things around. We can push people around. We can push people into people. We can push people into things and make them trip over. You know, just ignore those guys. They're just fucked. We can trip over marbles. It will hopefully interact with friction properly Or like, you know, you'll be able to slip over. Or like slip in mud. Trip on things, all that kind of stuff. And yeah, it's just modeled using a ball bot. Which is like funny. It's just funny, you know? But yeah, it works on like a... What is it? It's F10, isn't it? To F12? What's the exit? F8. If these guys weren't all like completely spazzing out, you can see that like... The characters... Oh, I need to just make it so that when the character goes down, it just stops. They just stop accelerating, you know? Is it F... It's F8, yeah. So yeah, if we like knock a character, they'll stabilize. Or if a character gets pushed and they're going too fast, they'll stop themselves from going further. In theory. These guys are in like an idle idle breathing like spring loop. It's funny. Why are they all doing that? I don't know. It's just weird shit. Yeah. Anyway, I'm wrapping up. Let me go. Let me go to bed. I want to go to bed. Let me go to bed. How's it going with this? Brilliant. Fuck. I don't know. The original idea was that the characters were going to be like hovercraft. So they would just be a capsule. We'd be doing line traces. And then the closer the line trace got to the floor, the more we would thrust them upwards. But then I was like, oh, fuck, I have to, like, calculate friction and shit manually and all that. And then I just thought, why don't we put, like, why don't we use wheels? But then I was like, well, wheels are just kind of like, like spheres. And spheres can move in, you know, they can strafe. Spheres can strafe if they're a wheel. So that's kind of the idea with this. Ugh. We'll be doing mutable plugin tutorials? Yes. When I start using it, I will cover the shit out of it, because it seems like a banger. So yeah, prepare for that. Good night, Charlie. Thank you, thank you. Right, who are we raiding? Who-ished raid? Can raid Crimson. How long's Crimson usually stream for? Raid the man. He's been going nearly 3 hours, so yeah. We'll raid Crimbo. Alright, well, we start the raid. Everyone enjoy Crimson's stream. He's a nice guy. And, have a great day-night. Have a great day-night cycle. If anyone wants to, like, look into ball bots on slopes and shit, if anyone's, like, invested in this stupid experiment, I'll be streaming tomorrow. And I think Crimson, never mind. Oh, you're wrapping up. I will send the raid elsewhere. Okay. Okay, we're not raiding Crimson. because he's about to finish up. So we will raid Chura. Or Odd Oculus just started. Yeah, we'll raid Chura. Alright. Alright, everyone have fun. Everyone had fun. Think about balls in the meantime. And then I will also think about balls. Look up First Crimson, Almarath. Or I think Crimson Dev is his YouTube. Or just I don't know what is on YouTube. Yeah, First Crimson, one word.